tumataas ang krimen, tumataas ang gamit ng droga. So, kahit ganito nakatindi yung ating mga problema, ang nireseta nila parati ay ayuda, press release, ano pa yung iba? Ayuda, press release, denial, ayuda, press release, at ito nga, branding campaign, slogan, logo, ay hala, di ba? Ano ba yan? Sabi ni Ma'am Marlita, masakit talaga attorney, ginagawa nilang patay gutom ang mamamayan, nabigyan mo lang ng 5K bigas, ayuda. Oo, yun. Di ba? Kanina, na, meron pa, di ba? So, ano yung mga sagot nila sa kahirapan natin? Ayuda, press, magpasara ng SMNI, mag-launch ng branding campaign. Ano ba? May nakikita naman tayo, of course, to be fair, maganda naman yung mga bagong pulisiya ng ating Agriculture Secretary, pero polisiya pa lang yun at mga plano, wala pa tayong nakikita na accomplishment. In the meantime, pwede siyang i-free pass, kadadating pa lang niya. Kamusta naman ang ibang mga kalihim ng iba't ibang departamento? May pa rin, di ba? Tingnan nyo. Meron pa pala, market visits. So, ayan, nagkakaproblema, taas ng kuryente, taas ng presyo, hindi sinasagot ng DTI yung mga trade issues involving agriculture. Pero dahil matataas ang bilihin, anong gagawin niya? Magma-market inspection. Merong isa pa dyan, hahawak ng itlog. Talaga, o raid, di ba? May problema ba tayo sa pagkain? May raid ang isa sa liderato dyan. Okay? May nagre-reklamo na hindi ko binabasa yung true emotion ng mga galit na tao. Kasi ganito yon. Kapag tayo ay natanggal sa social media, gawa nga ng language, o i-diminish tayo ng reach, anong mapapala nun? Naiintindihan naman ng tao kung ano yung emosyon. Ang problema ng komento mo is, pinipilit ako ay gumawa ng script mo. Ako ang mag-act out ng gusto mo. Alam nyo, kung gusto ninyo, pwede rin naman kayo mag-post sa mga walls ninyo. Bakit sa akin yung ini-impose yan? Binabasa naman at nakikita naman yung mga komento. May problema ba tayo dito? Ito, sabi ni Arnie, just like how Filipinos remembered Pinoy for the SAF 44 debacle, BBM will be remembered for ignoring Mindanao on December 2023. Sabi ni Relda, gusto niya parating ganitong oras daw ang live para mapanood niya kasi 30 ngayon sa London. O sige ma'am, at least 3 times a week ganitong oras. Kasi yung ibang times, talagang pressing yung issue, kailangan ko kagad mag-live. So normally, ang live ko after Karambola o sa tanghali nun, minsan late afternoon, pero ang next niyan talaga, gabi na. So either gabi ng 7:30, ganyan, or itong oras na. Kasi sa totoo lang, maaga po talagang matulog. Sabi ni Ma'am Karen, unfortunately, dahil exposed ako sa mga issues sa ibang bansa, halatang puppet din si BBM ng mga more powerful countries kasi parehas lang ng script ng mga liberal-led countries ang style niya. It's good insight, ma'am. Sabi ni Ray, a lot of room for improvement if they want to. Sabi ni Vianatics, mas okay gantong oras live mo kaming mga nasa outside Pinas, nakakapanood kami sa inyo. Yun na nga, kaya nga dati, di ba, iba-iba talaga ang oras ko ng live. Pero gayon pa man, sige, I will take that in consideration dahil syempre mahalaga din sa akin na nakaka-participate kayo sa ganitong klaseng usapan. Pwede bang pigilan yung NAIA na i-privatize? May magagawa pang paraan? Pwede ipa-TRO kung illegal. Pwede rin kasing patigil yan ng Pangulo, gawa ng kaya siya pumayag ay yung data na binigay sa kanya ay base sa ibang airport na dalawa ang runway. Hindi. Bakit di daw isinasa batas ang death penalty? Di ba pwedeng pagbotohan ng taong bayan ng bansa? Well, pwede siyang people's initiative. Tandaan nyo, may death penalty na po tayo noon. Pero nung naging presidente si Gloria, pina-retiro niya. Sabi na natin nagsipagtaas ang presyo ng bilihin dyan sa Pinas. Tanong, ano bang solusyon ang ginagawa ng kasalukuyan atin sa pagtaas ng presyo? Parang wala akong nakita kung di nangalap. Well, to be fair, nag-price ka dun sa bigas. At ngayon, nag-gaslight tayo na nag-work siya. Palibasa, karamihan sa kanila, hindi naman na nagpo-palengke. At a very particular kinds of price. So, hindi lahat ng bigas ay na-price cap. Gayun pa man, wow! Kung marinig ninyo, wow! Nag-work daw ang price cap, bumaba ang presyo ng bigas, pero pag pumunta ka sa palengke, ano po update sa kanyang build more? Hindi parehas nung kay PRD nung may balita. Well, wala kasi rin tayong naririnig. So, isa siguro yun, kailangan na mag-improve sa Marcos administration ay yung communications. Dapat kung may nangyayari, baka naman sakali, diba? Baka naman may accomplishment, hindi lang na i-report sa atin. So, unlike dati, yung build, may website pa yan. Sabi ni Ian, dati real-time din ang sipak sa gobyerno, naka-national broadcast ang dismissal sa public servants. Duterte pa rin. Ano daw pwedeng gawin kung this week wala pa rin presidente na magpakita? Maaaring magpetisyon sa Malacanang na maglabas ng report tungkol dun sa absence ng Pangulo. Sabi ni Hazel, ano na daw po ang balita kay Ka Eric at kay Doc Badoy? Well, day 4 na po ng kanilang hunger strike. At ito yung nakakalungkot. May ilang mga vloggers dyan na nagsasabing, 6 to 12 lang pala yung kanilang hunger strike. Ang itawag doon, diet. Oh, hindi sila kumakain the whole day talaga. So, day 4 na nang hindi sila kumakain. Sabi ni Six, we're happy Attorney Glenn andun sa US sa Smart Magic. Ano kaka-comment ko lang nina. Hallucinate sila. They need to be back in reality. Mahal pa rin ang bigas. O ano pa, fail pa rin ang logistics kasi tignan ninyo, yung mga magsasaka nagtatapon ng isip nyo, nagdadump tayo ng pagkain kasi nakasing halaga ng kamatis. Bakit? Again, nag-fail yung logistic system. Hindi na ikupunta yung ating mga magsasaka direct sa merkado. Ang bumibili sa kanila, kadalasan ay mga nagpautang sa kanila na traders din. Na maaari sabihin, sige, pag hindi nyo binigay yan sa akin sa murang presyo, maaari naman kaming magpa-import or maaari naman kaming bumili sa iba. Dahil nga, ang dami naman. Sabi ni Mollet, hindi na build kung di bit na lang. Sabi ni Arnie, let's accept the fact that PBBM is more of a follower than a leader. Nakikita ito ng mga under sa kanya kaya walang natatakot sa kanya. Sabi ni Kalyeng 72, bagong Pilipinas, ako ngayon lead. Kung hindi kumpleto ang budget, paano niyo gawa yun? Sabi ni Ben, walang clear na achievement si BBM, nga lang. Or kung meron man, hindi natin nararamdaman or hindi natin na-appreciate dahil nga sa kahirapan ng buhay. Legal ba sakaling ang sambayan ng Pilipinong gumawa ng petisyon? Kanino hindi po kayo magpipetisyon? Kailangan po, ang makakapag-compel lang po sa Kongreso ay yung judiciary. Para sa akin, ang Cebu lang ang nakilalang nangangailangan ng murang bigas. Paano na the rest of the country? Yes po, nakakasuhan po ang mga kongresista maliban lang para sa kanilang ginagawa in the course of committee hearings, privilege speeches, and so on. Kasi may immunity sila sa sinasabi nila sa mga okasyon na ganon. Sabi ni Arlene, they demand much kay VP Sara as DepEdsec pero pinupusasan naman sila. So muli nag-conduct ng branding campaign ang Marcos administration. At hindi nga lang talaga, alam niyo bang koronada ito, hindi kumbaga ilang beses nang na-postpone ito bagong Pilipinas launch. Siguro, wala namang kasing pressing need to do it, kaya madali i-postpone. Pero pangalawa, parang ang feeling ko, they're going through the motions. Nagagawa sila ng branding campaign, pero sa totoo lang, mas dapat nakatutok sa accomplishment. Nang sa ganon, yun na yung brand mo, yung accomplishments mo. Sabi ni Jose dito, sana matuto si PBBM sa nangyari sa admin ng tatay niya na nasira dahil sa tatay ni speaker para kasing ganun ulit. Sabi ni Rolly, unahin niya bumaba ang kuryente at presyo ng pagkain sapat na yung PR maramdaman ang pagbabago. Yan, you hit it right on the head. Nothing brands you better than your accomplishments, diba? No matter what, pagka, you let your accomplishments speak for yourself. Yes, well, given naman yun LGUs should also be helping farmers. Nandiyan na nga po yung yung mga subsidy and all that comes from the LGU. Sabi ni PRD number 1, ang ginagawa ni BBM is ruining his father's legacy. We better stop comparing him to the senior. Besides, if you think about it, Marcos Sr. had a lot of time to accomplish his projects. Sabi niya, ang employer ko na pulburon user, nawawala bigla pag may withdrawal, 2 weeks and detox. On that note, oy, maraming salamat kay Louie Soriano para sa pagpapadala ng super sticker. Sabi ni Mel, wala silang project kaya rebranding or sila nag-focus. Wala. So, pasensya na, medyo matatapos tayo ng maaga-aga ngayon kasi humihikab na ako at may karambola pag bukas. So, a few more comments and we'll go. Sabi ni Mercy, sama-sama tayo babangon, sigaw ni BBM ng eleksyon. Siya lang pala yun, hindi kasama taong bayan. Very disappointed. Sorry. Sabi ni Marlita, yun, the branding nakita natin kay PRD, kaya hindi natin nakakalimutan. Sabi ni Ami, parang ang gumagalaw bilang presidente SHOR Martin Romualdez at ang First Lady. Well, speculation pa po yan sa ngayon. But the point here is, anong iba-brand nila? Diba? Yun lang talaga ang tanong dito. Anong iba-brand nila? Samantalang wala pang major accomplishments. Matatapos na ang pangalawang, isang taon at kalahati na ang nakakalipas. Bukod pa dito, ang tumatatak sa isip ng taong bayan, yung parang yung oppressiveness ng Kongreso, yung kababawan ng mga solusyon para sa atin, ayuda, price cap, market visit, hawak-hawak ng itlog, and so on, yun ang nire-reseta sa atin. Seryoso na naman, ang seryoso na nila bigay serbisyo. Kasi hindi yan rocket science If you do the work, you complete your projects, and people will remember. Salamat muli sa pagsubaybay niyo sa amin. Pasensya na, inaantok talaga ako. And lastly, regressing daw ang brand ng BBM admin. Sabi niya, common ang paggamit ng pulburon dito sa Cayman, ganyan na ganyan ang galaw ng amo patulad. Okay. Maraming salamat. Uy, thank you very much. Maraming salamat sa lahat ng nagpadala sa super chat, super sticker, at saka nagpadala ng mga stars. Maraming salamat at sinamahan ninyo ako kahit ganito nakalate. And yes, we will try to do more lives ng mga ganitong oras. Sige po, we'll see you again very soon. Baka bukas mag-live na naman po ulit tayo. Maraming salamat. Thank you. Good night.
King size snack baka mo. Nessun King size wafer.
ng Pilipinas, BIFAR, no, Bureau of Fisheries and Aquatic Resources, ang nasira dahil sa pambobomba na naman ng water cannon ng dalawang Chinese ships, Chinese Coast Guard ships. Actually, mga kotsero, dapat gagawin ko po ito kagabi. Kaso parang wala pa masyadong reaction ng mga tao. So, ngayon, medyo meron tayong konting nakuhang mga reaction. So, ayun natin gagawin. Ito po yung nangyari kahapon. Ayan, o. Ay, ayan. Basahin ko na lang yung balita ng Philippine News Agency. Okay. Sabi, Chinese Coast Guard and Chinese Maritime Militia vessels water cannoned yet again Philippine resupply boats and their escorts that were on regular rotation and resupply mission to the BRP Sierra Madre in Ayungin Shoal. Ba't Sunday nakasulat dito? Baka Sunday nga nangyari. Alam ko kahapon to eh. O baka bago to. Bago. 3:13 p.m. Bago nga. Okay. The latest harassment damaged 2 of the 4 Filipino ships, but the RORE mission was carried out according to the NTF West Philippine Sea. Actually, meron pa nga kahapon, di ba? Ito yung nangyari kahapon, mapakita ko sa inyo. Yan, lakihan lang natin. Ay, wait. Nakasating volume. Ay, lalaki lang natin ng konti. Yan. Ito yung nangyari kahapon. Panoorin natin. Tagal. Yun. Yan yung nangyari kahapon. So, yun, kitang-kita, dalawang Chinese Maritime Militia ships yan, no? Di ba? Wagas, ibang level na ng violence ang ginagamit dito ng Chinese Communist Party, mga kodsero. Mabigat-bigat na to, hindi na to yung hindi na ordinaryo, kumbaga. Hindi lang yan, actually, meron pang tawag doon, meron pa silang tinawag na acoustic something. Wait lang. Yeah, it's something like that. Na nag-cause pa raw ng temporary na tawag dito. Discomfort sa ating mga Coast Guard tsaka miyembro ng BIFAR. So yung kahapon, yung sa BIFAR pala, yung kahapon sa BIFAR. Ngayon naman, Coast Guard RORE mission uli ito papuntang Ayungin. So dalawang magkasunod, mga kotsero. Hindi na to normal, mga kotsero. Actually, sa totoo lang, medyo nakakabagabag na to. Itong ganitong klase ng galawan ng China dito sa nangyayari na to. Hindi maganda to, mga kotsero. So, dalawa na pala. Isa kahapon sa BIFAR, isa kanina sa Coast Guard. So, ito nga. On Saturday morning, 3 Bureau of Fisheries and Aquatic Resources vessels providing humanitarian support to fisherfolk of Bajo de Masinloc or Scarborough were also water cannoned at least 8 times by CCG ships, while a long-range acoustic device, ito yung sinasabi ko kanina, na parang nagkaroon ng temporary discomfort. Siguro ingay ito, no? Yung mga high pitch noise, no? Long-range acoustic device caused severe temporary discomfort and incapacitation to some Filipino crew. Ginawa rin to ng China sa Navy rin ng Australia. Itong nakaraan lang sa side ng Japan, sa lugar ng Japan. Ginawa rin to ng China sa mga miyembro ng AFP. What do you call this? Navy ng Australia. Itong long-range acoustic device. So, kanina, nangyari, okay, December 2023, December 10, CCG and CMM, CCG is Chinese Coast Guard and CMM is Chinese Maritime Militia, vessels harassed, blocked, and executed dangerous maneuvers on Philippine civilian supply vessels in another attempt to illegally impede or obstruct a routine RORE to BRP Sierra Madre. Rory yung resupply mission, tawag nila doon. At Ayungin Shoal, CCG Vessel 5204 deployed a water cannon against the Philippine supply vessels, causing severe damage to ML Kalayaan's engine, disabling the vessel and seriously endangering the lives of its crew. Currently, PCG vessel BRP Sindangan is safely towing ML Kalayaan back to Ulugan Bay, Palawan. So, sinira talaga yung barko ng Chinese Coast Guard. This is really, hindi na hindi na maganda tong ganap na to. Sa totoo lang. At this does not bode well. Hindi maganda ang kapupuntahan nito. Dahil hindi lang kasi padalas ng padalas. Pero palala ng palala. Yun yung nangyayari dito eh. Palala ng palala. So, this time I think itong Pilipinas should do more than just make press statements. Parang parang nakakaloko na to eh. Diba? Kahit anong press statement po, wala naman nagbabago, ganun lang yun, laway lang yun. Diba? So ito ang sabi ng mga diplomats dahil dito sa ginawang pag-attack kahapon. Ito yung sa kahapon, hindi pa to yung sa kanina. So ang sabi ng EU, US, Japan at Canada. Sabi ng EU ambassador si Luc Veron, the 2016 arbitral award is a useful mechanism to peacefully resolve dispute as it is legally binding. Water cannons are not. Yun ang sinabi ng Luc Veron ng EU. Siyempre si US, si Mary Kay Carlson, ang sabi, we stand with our Philippine friends, partners, allies in support of a free and open Indo-Pacific. Si Japanese Ambassador Koshikawa Kazuhiko, sabi niya, they are seriously concerned about China's action, which he said not only endangered the lives and livelihoods but also pose a threat to the peace and stability in the waters. Yun ang sinabi ni Koshikawa Kazuhiko, ambassador naman ng Japan. Tapos inulit niya, we reiterate the importance of upholding international law, particularly UNCLOS and the 2016 Arbitral Award. Lahat sila bumabalik sa Arbitral Award. Canadian Ambassador David Hartman said Ottawa is condemning the dangerous and escalatory actions made by China. Canada reaffirms its support for the 2016 arbitral ruling, which is final and binding on the parties. Yun ang sinabi nila. So this is more or less the third time, pangatlong beses na to mga kucher, na ginawa ito ng China. Pero ito nga ang sinasabi ng China, paulit-ulit. Yan. Paulit-ulit itong sinasabi ng China. Ang sabi ng China, they have emphasized, nakuha ko to sa sa Global Times. Kaya nawala. Ayan, sa Global Times. Yan. Yung Chinese state newspaper. Kanilang propaganda machine. Ayan. Ang sabi nila, sa G7, the Chinese Foreign Ministry has emphasized that China's position on the so-called South China Sea arbitration and award is consistent, clear, and firm. Ang sabi nila, the arbitral tribunal violated the principle of state consent, exercised its jurisdiction ultra vires, and rendered an award in disregard of the law. Yun ang sinasabi nila. Na yung paghahabla pangaro ng Pilipinas, sabi nila, ang mali. Dahil nga daw, na-violate daw yung kanilang state immunity. Kasi prinsipyo, that's a legal doctrine na ang mga estado, hindi mo pwedeng kasuhan. Yung state. Pero yung person, pwede mo kasuhan. Lalo na, din sa Pilipinas, kapag naipag-transact o na private, o na in its private capacity, mga ganun. Or representative of a corporation, ganyan. So, pwede mong isu yung person, pero hindi pwede yung estado. Kasi nga, it's a state and it's a law-giving body. So, hindi mo pwedeng kasuhan yung estado. O sabi ng China, hindi mo pwedeng kasuhan, hindi mo kami pwedeng dalhin sa arbitration kasi estado kami, hindi kami pwedeng kasuhan. Yun sabi. Pero sumagot dyan ng PCA. Kapakita ko sa inyo yung sagot ng PCA, ha. Ang sagot ng PCA dyan, eto, nandito yung ruling mismo. Eto, kapakita ko sa inyo. Ayan yung ruling. Ayan yung ruling, ha. Sorry na, kapag hindi hirap kasi pag nakabiyahe ako eh. Hirap pag nakabiyahe ako. Wala akong masyadong dalang gamit. Okay, pero ito yung sinabi ng PCA tungkol dyan. Ang sabi, ang sabi dito sa mga gusto magbasa, puntahan nyo, download nyo yung Permanent Court of Arbitration Decision sa website nila. Nasa page 39 yan. Ang sabi ng page 39 ng PCA, the procedural history recounted in Chapter 2, China has not participated in the arbitration at any stage. So, hindi sila nag-participate, sabi ng China. Kasi nga daw, violation daw ng kanilang state immunity, tapos violation daw ng UNCLOS, etc. etc. So, ang sagot ng UNCLOS ay ng PCA, Permanent Court of Arbitration, ay ito. Under UNCLOS or under the convention, non-participation by one of the parties to a dispute, yung hindi raw pagsali ng isa sa mga partido dito sa usapan na to, does not constitute a bar to the proceedings. Hindi ibig sabihin na titigil ang hearing o ang kaso. Bakit? Nakasulat daw kasi sa Article 9, Annex 7. Sorry. Article 296, Item 1 ng UNCLOS, nakasulat daw doon, any decision rendered by a court or tribunal having jurisdiction under shall be final and shall be complied with by all parties to the dispute. So lahat doon ng desisyon ng PCA, lahat ng desisyon ng tribunal, kahit sinong korte o tribunal sa mga away-away na ganito, dapat sundin ng lahat ng mga nakapirma sa UNCLOS. In addition, Article 11 of Annex 7 provides that the award shall be final and without appeal. It shall be complied with by parties to the dispute. So, cannot be daw, sabi. Cannot be. Kailangan daw sumunod ng China kahit hindi siya nag-participate. Tapos, ano pa ba? Ayan. Ito pa, mayroon pa isa. So yun. So yun ang sinabi dito. Dahil miyembro ka ng UNCLOS, dapat mong sumunod. Dahil miyembro ka ng UNCLOS. Ngayon, pumirma daw kasi sila nung kailan ba to? 1996 daw eh. Sana yun? Wait. Pumirma daw kasi sila June 7, 1996 ang China sa UNCLOS. So, accordingly, they are both bound by the dispute settlement procedures provided for in Part 15 of the Convention in respect of any dispute between them concerning the interpretation or application of the Convention. So, ibig sabihin, hindi exempted si China. Yun lang yun. Hindi exempted si China. Bakit? Kasi pumirma ka eh. Pumirma ka sa UNCLOS. At ni-ratify nyo yan sa bansa nyo noong 1996. At nakasulat sa Part 15 ng UNCLOS na the dispute settlement provisions set out in Part 15 of the Convention were heavily negotiated and reflect a compromise. So pinag-usapan daw talaga nila yan. Yan dispute settlement procedures na yan. So, ibig sabihin, dahil pumirma ka sa UNCLOS, eh may jurisdiction sa'yo ang UNCLOS. So hindi mo pwedeng idahilan na ano ka na tawag dito. Hindi mo pwedeng idahilan na hindi may state immunity kami, ganyan. Well, pumirma ka sa UNCLOS at nakasama yan sa UNCLOS. So sorry ka. Yan ang parang sinasabi ng PC. So itong sinasabi ni China, alam naman natin excuse lang yan. Excuse lang yan kasi ayaw nilang isuko yung kanilang walang kwentang claim at walang basehang claim. Kasi nga pumirma na sila sa UNCLOS. It's simple mga kotsero, that's it. Walang diyan, walang question mark diyan. Ganun lang kasimple yan. Dahil pumirma ka sa UNCLOS, sinasabi ng PCA at sinasabi ng China, sinasabi ng PCA pala sa China, dahil pumirma ka sa UNCLOS, you are bound by all of its provisions. Sa lahat. Hindi yung pipili ka lang kung ano yung papabor sa'yo. Di ba? Ganun talaga yun. It is what it is. Treaty yan multinational treaty yan. Ganun talaga. So ngayon, pag sinabi ni China na bina-violate yung international law, bina-violate yung karapatan nila, etc., sila yung gumagawa nun. Sila yung nagva-violate at sila yung gumagawa ng kabalbalan dyan sa West Philippine Sea. At ang nakakatawa, mga kotsero, merong mga Pilipino na kinakain yung kasinungalingan ni China. Kinakain yung echas ni China. Yun nakakatawa dyan And I think, it's not because they're not patriotic. Hindi yun Hindi ako naniniwala na hindi sila patriotic, na hindi nila mahal ang bansa. I think mahal nila yung bansa. Pero, yung pagmamahal nila ay nakabase sa opinion at paniniwala ng politiko na pinapanigan nila. Kaya nagkakaganito, kaya nagkakagulo. I think alam naman natin yun hindi naman tayo pwedeng mag-claim na hindi kami lang ang nagmamahal sa bansa kasi ganito o kami lang nagmamahal sa bansa kasi ganyan. Hindi. I think itong mga tao na to na pro-China mahal naman talaga nila ang Pilipinas. Yun nga lang, ang pagmamahal nila ay nakadepende sa kung paano minamahal ng politiko nila ang bansa. Nagkataon, yung politiko nila, pabor sa China. So it is what it is. Let's call it as it is. Kaya nga dapat magsalita na dito si VP Sara should start making her position clear pagdating dito sa China. Kasi maraming tumitingala kay VP Sara, including myself. Ako sabi ko kasi kung 2028 na bukas, iboboto ko si VP Sara na presidente. Kung 2028 na bukas. Pero ihintayin ko muna yung statement niya tungkol dito. Kasi I think the Philippine government is clear. Malinaw ang posisyon ng gobyerno ng Pilipinas pagdating sa China. And I think maraming Pilipino, in fact, 70% or 80% ng mga Pilipino nagsasabi na ayaw na natin kay China. So, I think, palagi ko lang naman, she can do what she wants. Well, di ba? Siya naman vice president. Hindi naman ako. She can do whatever she wants. Pero, I think for clarity's sake, para alam na natin lahat, para alam natin lahat kung ano ba yung dapat tayuan ng mga supporters ni Bongbong at supporters ni Sara. Dapat marinig natin yung side naman ni VP Sara kasi for the longest time we haven't heard from VP Sara on her position dito sa Chinese harassment dyan sa West Philippine Sea. We haven't, well, di natin alam Actually ako di ko alam. Is she tinatanggap ba niya yung posisyon ng tatay niya na pro-Beijing stance? Or totoo ba ang kwento-kwento na siya yung medyo rebelde sa pamilya nila at kokontra siya sa sinasabi ng tatay niya tungkol sa sa Beijing? I'm hoping the latter. I'm hoping na doon siya sa huli yung kokontra siya sa Beijing. Kasi slogan pa lang niya, mahalin natin ang Pilipinas Pilipinas. Hindi naman sinabing mahalin natin ang Pilipinas papuntang China Hindi naman yun Di ba? Sinasaktan na yung ating mga Pilipino, sinasagasaan na ng mga barko ng China yung mga mangingisda. So parang... And as far as President Bongbong Marcos is concerned, he needs to be more firm. I think si President Bongbong Marcos, Mr. President, kailangan mong tumayo. Kailangan mong, you have to show your spine when it comes to this issue. Alam namin, nakita namin, nakipag-partner ka kay Japan, nakipag-partner ka kay Australia, kay US, etc., etc. But there are other countries and they have their own problems. May iba silang problema. Tayo sa Pilipinas, anong gagawin natin? As a country, aside from forming alliances, what are we going to do? Papagalitan na naman ba natin si Wang Zhilian, yung ambassador ng China? Are we going to do something? Magagalit lang ba tayo? Maglalabas lang ba tayo ng statement? Or what are we going to do? Mr. President, we have to hear you. Alam namin, galing ka sa sakit and thank God, gumaling ka na. But, I think we need you this time. We need you more vocal. Kailangan namin makita yung na hindi ka na sa kung ano mang event na meron kang speech. Hindi, we need you to be more we need to see your backbone on this issue, Mr. President. And I guess that's the long and short of it. Kasi nakakaano na rin hanggang kailan natin to titiisin? Will we do something sa China? Short of going to war. Of course, di naman natin kaya yung gera. Pero what else can we do? Can we shift our exports to somewhere else? Diba? Pwede ba tayong mag-umpisa na ng manufacturing sa Pilipinas para dito na lang gagawa ng mga China-made products? Pwede naman gawin dito yung lahat Babaguhin na ba natin yung constitution natin para dito na mag-invest ang mga foreigners? Papayagan na ba natin ang 100% foreign investment in certain industries? Di ba yung mga ganun? That's doing something for the Filipinos short of going to war with China. Di ba? Tanggalin natin ang ating umbilical cord sa China. Tanggalin natin, di pala umbilical cord, yung dextrose. Tanggalin natin yung dextrose natin sa China. That's the least we can do. Di ba? So, and tayo mga ordinaryong Pilipino, hindi natin kaya gawin yan, na makagawa lang dyan yung mga policy makers natin. So, sana kahit marinig lang muna natin yung plano. It doesn't have to be tomorrow. Hindi naman kailangan ma-execute na yan bukas. Pero at least marinig man lang, di ba? Para alam natin kung saan direction papunta ang Pilipino. So, yun mga kutsero, hanggang dito lang po muna tayo sa video na ito. Please don't forget to subscribe sa ating Coach Reality YouTube channel. And mga kutsero, we will be having our live stream soon. Konting panahon na lang, tatapusin ko lang yung finals. Pero pagtapos ng finals, yan, live stream tayo ulit. But, yun, maraming pong salamat sa inyong patuloy na pagsuporta. God bless you and see you next time, guys. Bye!
Ang cheese dog ko ay cheesy yum-num. CDO Idol Cheese Dog, yum-num for the fam.
Support from viewers like you makes this program possible. Please give to your PBS station.
Of all the objects in the cosmos,
Planets,
stars,
galaxies.
none are as strange, mysterious, or powerful as black holes.
Black holes are the most mind-blowing things in the universe.
They could swallow a star completely intact.
Black holes have these powerful jets that just spew matter out.
First discovered on paper,
On the back of an envelope, some squiggles of the pen.
the bizarre solution to a seemingly unsolvable equation,
A mathematical enigma.
Einstein himself could not accept black holes as real.
People didn't even believe for many years that they existed.
Nature doesn't work that way.
Yet slowly, as scientists investigate black holes,
by observing the effect they have on their surroundings,
evidence begins to mount.
that is the proof of a black hole.
Millions of times the mass of the sun.
cutting-edge discoveries show.
We did it.
Black holes are very real.
I thought it was crazy.
I said, holy.
But what exactly are they? If we could visit one, what might we see? With their immense power, do black holes somehow shape the very structure of the universe? Is it possible we might not exist without them?
It's quite a journey.
Black Hole Apocalypse, right now on Nova. There are apocalyptic objects in the universe, engines of destruction, menacing and mysterious. Black holes. Even scientists who study them find them astonishing.
Black holes can sort of blow your mind. I'm amazed that these objects actually exist.
Black holes defy our understanding of nature.
Black holes are the greatest mystery in the universe.
They're completely invisible, yet powerful beyond imagining. They can tear a star to shreds.
Black holes actually will eat anything that comes in their path.
You really want to avoid them at all costs.
Black holes even slow time. Once thought too strange to be real, black holes shatter our very understanding of physics. But we're learning they may somehow be necessary for the universe we know to exist.
They might well be the key players.
What are these strange, powerful objects? Outrageous and surprising. Where are they, and how do they control the universe? The search for black holes is on, and it will be a wild ride across the cosmos to places where everything you think you know is challenged, where space and time, even reality, are stranger than fiction. And we're starting that journey at a very unlikely place. Here, at a remote location in Washington State, where for the first time, a radical new experiment has detected black holes. It originated over 50 years ago, when a few visionary scientists imagined a technology that hasn't yet been invented. Searching for something no one is certain can be found. The experiment is daring and risky. Failure could mark their lives forever. But they don't fail. Right here in these facilities, they make a remarkable discovery. In the early hours of September 14th, 2015, they record a message. It looks and sounds like this. Just a little chirp. But that chirp is epic, monumental. The signal traveled over 1 billion light years to reach us. It started far, far away. And what it tells us is this. Somewhere in the cosmos, over 1 billion years ago, two massive black holes circle each other in a fatal encounter. Closer and closer they come, swirling faster and faster, until finally they slam together. The black holes create waves that spread outward, just like vibrations on a drum. A ringing in the fabric of space itself. The collision creates a massive blast, putting out 50 times as much power as the entire visible universe. It sends out a wave not of heat or light or sound, but of gravity.
This gravity wave is moving its way through the universe at the speed of light.
The wave races by stars. On the young Earth, supercontinents are forming. Microscopic organisms have just appeared.
Washing over one galaxy after another, after another.
Dinosaurs roam the Earth.
The wave is still moving.
It zooms through clouds of dust.
And then it nears the Milky Way galaxy.
The Ice Age is just beginning.
We're troglodytes, drawing in caves.
The wave reaches nearby stars. Albert Einstein is in the 6th grade. The wave approaches as close as Alpha Centauri. At midnight on September 13th, 2015, it is as close as Saturn. Finally, over 1 billion years after the black holes collide, the wave reaches us. It strikes a pair of revolutionary new observatories, the sites of the daring experiment. This is LIGO, the Laser Interferometer Gravitational Wave Observatory. The experiment, 50 years in the making, has finally hit the jackpot and opened an entirely new way of exploring the universe. For 400 years, almost everything we've observed in space has come to us in some form of electromagnetic energy. That little chirp is different. What hits the Earth in September 2015 is a gravitational wave, a squeezing and stretching of the very fabric of space. It produced no light. No telescope could ever see the collision. We needed an entirely new kind of observatory to detect it. That wave is new and direct evidence of one of the strangest mysteries in our universe, black holes. Most of us have heard of black holes. They're invisible, powerful.
We're talking about things that are 1 billion times the mass of the sun.
Bizarre.
A physical entity with infinite density. No beginning, no end.
They pull things in and warp light. Approach one, and time itself begins to change.
Gravity is so intense that a moving clock will tick slower.
Time will become so slow for you that you will watch the entire future of the universe unfold before your very eyes.
Fall in, and you'd be squeezed as thin as a noodle.
You'll be extruded through the fabric of space and time, like toothpaste through a tube.
Today, we know more about black holes than ever before. But the more we learn, the more mysterious they become.
They're the most exotic objects in the universe. We don't have the physics to describe them.
No matter how well you understand them, they remain unreachable in some sense.
Now, gravity's at maximum. Man is about to enter the black hole.
So black holes have a pretty fierce reputation. And if you want a villain for a sci-fi movie, cast a black hole. But in reality, what exactly is a black hole? And where do they come from? You might think a black hole is like this, an object, but it's not. It's a hole in the fabric of space, a place where there is nothing except gravity, gravity at its most intense and overwhelming.
So if black holes are all about gravity, gravity at its most extreme, what exactly is gravity?
We're all familiar with gravity. Friday.
It rules our lives. But even so, for a very long time, how gravity actually works was one of the greatest mysteries. Over 300 years ago, Isaac Newton was fascinated with the behavior of moving objects. Eventually, he figured out his laws of motion. They work so well, we still use them today. But Newton's laws can only describe gravity's effects, not explain what it is. And here's where Albert Einstein comes in. Like Newton, he thinks about objects in motion. And he wonders what gravity actually is. Is it a force, or could it be something else? Here's what concerns Einstein. Take this apple. I can't move it without touching it. But if I drop the apple, it moves toward the earth. But what if I take my hand away? And the floor, and the basement, and the floor below that, then what happens? The apple just keeps falling. Einstein realized that gravity had something to do with falling. Now, if I throw the apple, it falls along a curved path. But imagine I could get the apple moving much faster. Eventually, if I get the apple moving really, really fast, say 17,000 miles an hour, its curved path matches the curve of the Earth. The apple is in orbit, falling freely, just like the International Space Station and the astronauts inside it. According to Einstein, the apple and the space station and the astronauts are all falling freely along a curved path in space. And what makes that path curve? The mass of the Earth.
Einstein came up with a supremely simple concept, and that is that space and time is bent by the Earth and by the sun and by all the objects in the world.
So according to Einstein, the mass of every object causes the space around it to curve.
And that was Einstein's conception. There are no forces anymore. There's just objects bending space-time and other objects following the straightest line through it.
All objects in motion follow the curves in space. So how does the Earth move the apple without touching it? The Earth curves space, and the apple falls freely along those curves. That, according to Einstein's general theory of relativity, is gravity, curved space. And that understanding of gravity, that an object causes the space around it to curve, leads directly to black holes. But it's not Albert Einstein who first makes the connection between gravity and black holes. It's another scientist.
Karl Schwarzschild was a German astronomer, head of the Potsdam Observatory in Germany.
Ever since he was a teenager, he'd been calculating complicated features of planetary orbits.
As Einstein unveils his theory of gravity in 1915, Karl Schwarzschild is in the German army, calculating artillery trajectories in World War I.
And just weeks after Einstein presented his papers, Schwarzschild, then on the Russian front, quickly got a copy and was mapping the gravitational field around a star.
Einstein had gotten at it through a series of approximations, but Schwarzschild, sitting on the front with bullets and bombs flying, calculated an exact solution to Einstein's theory and sent it to Einstein. Einstein was astonished. He hadn't even imagined that you could solve these equations exactly.
But Schwarzschild isn't done. In his solution to Einstein's equations, he discovers something Einstein himself had not anticipated.
Schwarzschild said, I can calculate this strange distance from a gravitating object that represents a kind of boundary.
Schwarzschild mathematically concentrates a mass, for example, a star, into a single point. Then he calculates how that mass would bend space and curve rays of light passing nearby.
As he, through his mathematics, aimed particles of light or matter towards this point, there was this boundary surrounding the point at which the particles would just stop. The particles disappeared. Time stopped.
Schwarzschild has discovered that a concentration of mass will warp space to such an extreme that it creates a region of no return. Anything that enters that region will be trapped, unable to escape, even light.
It's like those roach motels. You can check in, but you can't check out. And once you go across that boundary, even if you can sail through, there's nothing you can do to get out, there's nothing you can do to signal out. It becomes this strange, cut-off portion of space.
Schwarzschild has discovered is that any mass compressed into a small enough space creates what we today call a black hole. But Albert Einstein, whose own theory of gravity predicts such a thing, cannot believe it can happen in the real world.
Einstein didn't think that nature would act like this.
He didn't like this idea.
Karl Schwarzschild becomes ill and dies before he has a chance to further investigate his own discovery. 2.5 years later, in November 1918, World War I ends. The strange theoretical sphere discovered by Karl Schwarzschild seems destined to be forgotten. Nothing but a curious historical footnote. But in the coming decades, physicists learn more about the atom and about how fusing atoms powers stars, a process called nuclear fusion. Some begin to wonder if something like a black hole could actually come from a star. But not just any star. It would have to be big.
Stars are born in litters, and you get a distribution of sizes and masses. Thousands of little stars, and a few big stars, very big stars, incredibly massive.
Stars are in many ways similar to living creatures. Like humans, they have life cycles.
Investigating stars' life cycles in the 1930s, two visionaries, Subramanian Chandrasekhar and Robert Oppenheimer, discover that the most massive stars end their lives very differently from smaller ones.
The life cycle of a star really depends on its mass. The mass of a star determines what's going to happen after it finishes burning its hydrogen fuel.
All stars start out burning hydrogen, the lightest atom, fusing hydrogen atoms into helium, working their way up to heavier elements. Gravity wants to crush the entire mass of the star, but the enormous energy released by fusion pushes outward, preventing the star from collapsing.
Stars are stable because we have an outward moving pressure due to nuclear fusion, and that's balancing with the inward force of gravity.
Smaller stars can't fuse elements heavier than helium. But in the most massive stars, fusion crushes heavier and heavier atoms, all the way up to iron.
Iron is such a massive element, it has so many protons in it, that by the time you fuse iron, you don't get any energy back out.
Iron is a dead end for stars. Fusing atoms larger than iron doesn't release enough energy to support the star. And without enough energy from fusion keeping the star inflated, there's nothing to fight gravity.
And gravity wins. And so the entire star collapses.
Very rapidly, trillions of tons of material come crashing down, hit the dense core, and bounce back out, blowing off the outer layers of the star in a massive explosion. A supernova. The more mass, the more gravity. So if the remaining core is massive enough, gravity becomes unstoppable.
There's no known force to prevent the collapse to an infinitesimally small dot.
Gravity crushes the stellar core down smaller and smaller and smaller until all its mass is compressed in an infinitely small point. A black hole. The theory makes sense, but most physicists remain skeptical about black holes.
Einstein and Eddington, all the sort of, preeminent astrophysicists in the 1930s to 1950s, did not believe that they were actually real. It remained a solution, a mathematical enigma for a very long time. So it took a long time for people to even start looking for them.
It's not until the 1960s that the idea of a supernova creating a black hole is taken seriously. Princeton physicist John Wheeler, who had originally been a skeptic, begins to use a name from history for these invisible objects: black hole.
The term black hole actually originates in India. The black hole was the name of an infamous prison in Calcutta.
Still, no one has ever detected any sign of a black hole. Then in 1967, graduate student Jocelyn Bell discovers a strange, extremely tiny, dead star that gives off very little light. A neutron star. The cold remains of a stellar collapse. The neutron star gives astronomers more confidence that black holes, much heavier dead stars, might also exist. A half-century after Carl Schwarzschild mathematically showed that black holes are theoretically possible, scientists have identified a natural process that might create them: the death of large stars.
So these giant supernova explosions of extremely massive stars make black holes.
Any star that is born with a mass that's about 10 times the mass of the sun or higher will end in a black hole. So our galaxy is replete with little black holes, which are the stellar corpses of generations of stars that have come and gone.
So what are these invisible stellar corpses like? Imagine I'm exploring space with some advanced technology for interstellar travel so that we could visit a black hole, maybe one in our own galactic neighborhood. This particular black hole isn't very big, only about 10 solar masses, meaning 10 times the mass of the sun. And like all black holes, it has an event horizon. A distinct edge to the darkness. That's the boundary Carl Schwarzschild first discovered. The gravity is so strong that nothing can escape, not even light. And that's where we're going. As we get closer, some very strange things begin to happen.
Look at the edge of the black hole. See how the image of distant stars is distorted and smeared into a circle? That's gravitational lensing. The black hole's extreme gravity bends the path of light passing by, so that a single point of light, like a star, briefly appears as a ring around the event horizon. I'm now deep in the black hole's gravity well, and we're going to start experiencing the effects. The extreme gravity actually slows down time relative to the Earth. From their point of view, I appear to be slowing. But from my point of view, time on Earth is speeding up. Now let's say I want to get even closer by taking a spacewalk. The way the black hole slows down time is about to get even more pronounced. To keep track of the changes I'm about to experience, I'm turning on this strobe light. It'll blink once a second. From here, I can see the shadow of the event horizon approaching, and my light blinking normally. But watching from the ship, the closer I move toward the black hole, the more slowly I appear to move. The pulses are nearly infinitely spaced. So it looks as though I'm frozen in time. For me, everything is completely normal, even when I reach the event horizon. If you waited long enough, maybe millions or billions of years, the ship would finally see me disappear. And that's the last you'd see of me. What's inside a black hole? That's still a mystery. And even if I find out, I can never go back and tell you. But I can say this. Black holes may be dark from the outside, but inside they can be bright. I can watch the light from the galaxy that's fallen in behind me, and that's the last thing I'll ever see. Unfortunately, the fun is about to end. Now that I've crossed the event horizon, I'm falling toward the center, where all of the mass of the black hole is concentrated. And I'm beginning to get stretched. As I fall in, the gravitational pull at my feet is stronger than at my head, and my body is starting to get pulled apart. I'll be stretched as long and thin as a noodle, spaghettified, and ultimately I'll end up completely disintegrating into my fundamental particles, which are then crushed to an infinitely small point. A singularity, where everything we understand about space and time breaks down. Or maybe the black hole, less than 40 miles across on the outside, is as big as a universe on the inside. And as I pass through, my particles will join the primordial soup of a new beginning. So that's what theory tells us we might experience if we could travel to a black hole.
Fit is now. Shop your favorite brands at up to 70% off with Last Flash Extra.
How can we know for sure? How do you investigate something we can't even see?
There are ways to investigate if something is happening somewhere, even if I can't see that thing directly. Take Yankee Stadium. What's happening inside there? Is there a game going on? I can't see the field. I can't see any players or baseballs or bats, but I can definitely tell if there's activity around the park.
It's pretty clear something is going on. It might seem obvious, but whatever it is, I can learn a lot just by observing the happenings around the stadium. And these do look a lot like baseball fans. And that's the way we investigate black holes, by observing the effect they have on their surroundings. But what sort of effects? How might a black hole reveal itself? Starting just before World War II, two monumental discoveries are about to radically change astronomy. In 1931, Bell Labs engineer Carl Jansky picks up mysterious radio waves emanating from deep space. Then the sky gets even stranger. When scientists mount Geiger counters on captured German rockets and discover the cosmos is also full of X-rays. These discoveries give astronomers important new tools that will revolutionize the hunt for black holes and dramatically expand our vision.
What our eyes can perceive is a very narrow part of the electromagnetic spectrum.
If the electromagnetic spectrum were laid out along the Brooklyn Bridge, the portion we can see with our eyes would be just a few feet wide. Electromagnetic radiation includes waves of many different frequencies: radio waves, microwaves, infrared and ultraviolet light, X-rays, and gamma rays. Radio and X-ray astronomy open up the sky, revealing dim or even invisible objects, blasting out powerful energy no one knew was there.
They began to realize that this very placid thing that we see out there, all this very quiet thing that looks like nothing is happening and the only thing that's moving is the planets, found out that there was madness going out there, there was chaos out there.
X-rays come from the high energy end of the spectrum. What is creating all this energy? This much is certain. Whatever the source, it is invisible to ordinary telescopes, and it is hot.
X-rays come from things which are at temperatures of millions of degrees, even tens of millions.
One of the first of these X-ray sources to catch the attention of astronomers is named Cygnus X1.
Cygnus, it was in the constellation Cygnus. X, it was an X-ray source. 1, it was the first one you found.
In 1970, Paul Murden is a young English astronomer trying to secure his next job.
I was a research fellow. I was coming to the end of my 3-year contract, and I thought, what can I contribute to finding out what these things are?
Murden works in a 15th century castle surrounded by telescopes, the Royal Observatory. Using the largest telescope in England, he begins searching the area of the constellation Cygnus, the Swan. He decides to hunt for pairs of stars. Pairs of stars are called binaries. They may sound exotic, but they're not at all uncommon. Many of the stars we see, perhaps half, are actually binaries, pairs of orbiting stars locked together by gravity. But Murden wonders, is it possible there are binaries where only one of the stars is visible?
I thought that maybe there was a kind of a star system in which there was a star, one ordinary star that made light, and then there was another star nearby that made X-rays.
The telltale sign of a binary is that the stars are moving around each other. So Murden begins searching for a visible star that shows signs of motion.
Sometimes it's coming towards you, sometimes it's coming away, sometimes it's coming towards you, sometimes it's coming away.
When the star is moving toward us, it appears more blue as the wavelength of its light gets shorter. Moving away, it appears more red as the wavelength of its light gets longer. This is known as Doppler shift.
After looking for color changes in hundreds of stars in the area of Cygnus, Murden spots a possible suspect, a visible star whose light is shifting as though moving around.
It very clearly was a binary star, a double star. The star was moving around and around in a period going round once every 5.6 days.
Polydent, may strong kape, gum comfort at food blocker. Bibig mo nang nagsabi, mag-Polydent palagi.
But whatever it's going around can't be seen.
There was no trace in the spectrum of the second star. There was one star there, there wasn't the second star there.
Murden has a binary pair in which only one star is visible. The second object emits X-rays, has enough mass and gravity to dramatically move a star, but gives off no light. Could it be the corpse of a star massive enough to become a black hole?
The crucial issue in deciding whether Cygnus X1 was a black hole was to measure the mass of the X-ray emitting object.
It would have to be very massive, at least 3 times the mass of our Sun. If not, it's probably just a neutron star. A collapsed star that's dense, but not heavy enough to be a black hole.
So the observers needed to come up with a conclusion that the dark object, the X-ray emitting object in Cygnus X1, is heavier, hopefully substantially heavier than 3 solar masses.
From his observations, Murden is able to make an estimate of the mass of the invisible partner.
And the answer came out to be 6 times the mass of the Sun. So there was a story then that Cygnus X1 was a black hole. And the key to the argument was that the mass of the star you couldn't see was more than 3 solar masses. When I'd finished writing it all out, I sat back and thought, it's a black hole.
This would be the first actual detection of a black hole. It's a huge claim, and Murden will have to convince skeptics, starting with his boss.
The Astronomer Royal, Sir Richard Woolley, he didn't really go for black holes. It's all fanciful. A lot of people in California are talking about it. A lot of funny people in California, you know, a lot of hippie-type people.
People like theorist Kip Thorne.
So I was nervous about it. I was nervous about the scale of the discovery, and actually so were other people all around me. I was working with a fellow scientist, Louise Webster, and we were modest about the claim that we were making because we knew what people would think of it. And if you look at the paper we published, it just mentions the word black hole once, right at the end. We think this might be a black hole.
The Paul Murden Louise Webster paper appears in September 1971. Other astronomers agree it could be a black hole, but no one knows for sure. 3 years later, Kip Thorne and the noted British physicist Stephen Hawking make a now famous wager about Cygnus X1.
We made a bet as to whether Cygnus X1 really was a black hole or not.
The bet is partly in jest. Both men hope it is a black hole. But Hawking, not wanting to jinx it, bets against his own wishes.
Stephen claims that Cygnus X1 is not a black hole, and I claim it is a black hole. And so we signed that bet in December 1974. And gradually the case that it really was a black hole became stronger and stronger and stronger. So in June of 1990, Stephen broke into my office and he thumbprinted off on this bet, conceded the bet in my absence. I came back from Russia and discovered that he had conceded.
Now by 1990, the evidence of Cygnus X1's mass may be strong enough to settle a bet between two friends. But the original estimate wasn't precise enough to be definitive. In order to calculate mass, Paul Murden had to rely on rough estimates of the distance to Cygnus X1, which varied by a factor of 10. And the question wouldn't be answered for another 20 years, until astronomer Mark Reed became intrigued by the puzzle. Reed is an astronomer at the Harvard-Smithsonian Center for Astrophysics when he sets out to conclusively prove that Cygnus X1 is a black hole by measuring its precise mass.
But how can you measure the mass of an invisible object? Using laws developed by German astronomer Johannes Kepler in the 1600s, it's possible to calculate the mass of a celestial object, but only if you know its distance.
Distance in astronomy is absolutely fundamental. If you don't know distance, you don't know what the object is. It could be a very nearby firefly-like thing. It could be a very distant, huge star, much, much bigger than the sun.
So to get the true, precise mass of Cygnus X1 and confirm that it is a black hole, Reed needs to know how far away it is. But how can he measure the distance to a star? The secret lies in a familiar phenomenon, parallax. It's what our eyes and brains use to see in 3 dimensions.
You can put your finger up at arm's length, look at it, and close one eye, closing my left eye, and I'm looking at my finger relative to the wall in the background. Now if I open my eye, close my right eye, I see my finger has appeared to move with respect to the original position. And that's because our eyes are separated and we view from different vantage points.
To use parallax to measure distance to an object in the sky, astronomers let the motion of the Earth provide the 2 different vantage points.
Imagine Cygnus X1 is right here, and the Earth and the Sun are over there. The Earth goes around the Sun once a year. And in the springtime, the Earth ends up on one side of the Sun, and we observe Cygnus X1 along a ray path like this. And then 6 months later, the Earth goes around the Sun to the other side. We get a different vantage point from Cygnus X1.
Now he has a triangle that goes between the Earth at its 2 positions and Cygnus X1. We know the base of the triangle, the diameter of Earth's orbit. And the principles of geometry tell us that all we need to calculate the distance is the size of the angle at the top.
And we measure this very small angle here at the point at Cygnus X1. And then from direct geometry, we can calculate the distance to Cygnus X1, and from that infer a very accurate mass.
The concept is simple, but Cygnus X1 is so far away that the angle to be measured is minuscule, a tiny fraction of 1 degree. It's smaller than the angle spanned by Abraham Lincoln's nose on a penny in San Francisco, viewed from New York. Because the angle is so
Let's give a second chance naman daw sa peace talk. Sabi ni Cheese Escudero. Yun, matindi-tindi itong sinabi ni Cheese. Okay. Sabi daw ni Cheese Escudero, let's give peace a chance. Second chance daw sa peace talks. Woo, saka pa. Ay, taka sa inyo. Ito yung balita, guys. Ayan. Ayan. Escudero! Ayan, pasensya na akong baliktad kasi yung phone ko yan. So yan daw. Bigyan ng second chance ang Pistons. Okay, basahin natin guys, basahin natin. Baka naman may dahilan siya, di ba? Baka naman yung dahilan niya is what do you call this? Substantial, di ba? Or kapani-paniwala. Baka naman pwede, di ba? Why not? Anyway. So ito sabi ni Cheese Escudero. Sabi niya kanina, ito yung sabi ng balita, suportado ni Senator Francis Cheese Escudero ang plano ng Marcos administration na muling buksan ang peace talks o usapang pangkapayapaan sa Communist Party of the Philippines, New People's Army, National Democratic Front. Yan ang sinabi ni Cheese Escudero kanina. Sabi niya, para sa akin, anumang mapayapang paraan para maresolbahan ang patayan, birian at awayan sa pagitan ng mga Pilipino o sa pagitan pa ng Pilipinas at ng ibang bansa ay para sa akin hindi dapat pinipigilan. Diba? Grabe. Kamusta naman ang motherhood statements nito? Shout out sa motherhood statements. Okay, sabi ni Escudero sa panayam sa radyo noong Sabado. Okay. Dapat bukas palagi ang isang mapayapang paraan tulad ng pakikipag-usap para maresolba ang anumang hindi pagkakaunawaan. Wow. Yan yung yan yung mga statements na yung pag binabanggit mo pag yung mga walang laman. yung mga kwentong barbero, yung kwento ka lang ng kwento pero walang alaga. Yan yung mga sinasabi ngayon ni Jesus Escudero. Okay, sa pagpano ng CPP Founding Chairman Jose Maria Sison, noong nagdaang taon, sinabi ni Escudero na dapat bigyan ng oportunidad ang liderato ng komunista para maipakita ang kanilang sinseridad sa isang round ng negosasyong pangkapayapaan. Wow, hindi lang yata kinumpara pa sa pelikula. Hindi ba sa mga pelikula maraming beses na nabigyan ng second chance ang mga nagkakamali? Wow! Ganda ng example mo, sir! Di ba sa pelikula? Ano nakala mo sa gobyerno natin? Fantaserye? Ano nakala mo sa gobyerno natin? Telenovela? Kaya palang gugulo nyo dyan. Nakala nyo, pelikula tong itong ating gobyerno. Kaya pala puro artista. Kaya pala puro artista. Kasi parang pelikula raw. Ano ba yan, Senator Cheese? Pelikula. Hindi kaya frustrated actor ko si Senator Cheese. Gusto mag-artista, hindi lang natuloy. Okay, pamahalaan daw kasi tayo. Well, in fairness, si Risa Ontiveros may pangarap mag-artista ng bata. Tapos ang ending niya, senadora. baka si Senator Cheese ganun din. Nagplano mag-artista pero hindi natuloy. Okay, sabi, pamahalaan tayo, wala tayong karapatan na maubusan o mawalan ng pasensya. Wala tayong karapatang magalit o parating maging galit sa sino mang sektor, grupo o tao. Hindi. Mali naman to. Hindi naman sinasabing wala kang karapatan maubusan o mawalan ng pasensya. Kasi sa batas, ito abogado naman ng Senator. Di ba sa konstitusyon natin, may trabaho ang gobyerno na panatilihin ang na bantayan ang ating soberenya, ang estado, bantayan ng estado. That's one. Tapos, peace and order, ang trabaho din ng gobyerno yan. Implementation ng karapatang pantao. Ano ba? Yung mga ganun ba? So, hindi ibig sabihin na dapat hindi ka maubusan ng pasensya o gano'n. Kasi meron kang kailangan sundin ng mga batas. Hindi umuubra ang pasensya sa batas. Sorry. Hindi umuubra ang mga pasensya sa batas. Walang gano'n. Hindi totoo yun. Kung gano'n lang, ba't pa tayo nagkorte? Diba? Huwag na tayo magbatas. Doon lang tayo sa anong feeling natin. Naawa tayo, o di dismiss natin yung mga kaso. Pero naman kasi yung blue. Yung gusto ni Senator Cheese, ito yung mga Rafi Tulfo Justice. Yung Rafi Tulfo Justice, yung mga tipong nakakainis. Parusahan na yan, kulong na yan, tanggalan ang trabaho yan. Buti pa si Willie, namimigay ng jacket eh. Namimigay ng pera. Si Rafi Tulfo, hindi. Nagtatanggal ng trabaho. Diba? Anyway. Ay, nako. Tsaka meron kang karapatang magalit. Ang gobyerno may karapatang magalit sa mga sektor. Lalo na kapag yung sektor na yan ay gustong pabagsakin ng gobyerno. Tulad na CBP at PNP. They're not ordinary citizens. Hindi sila ordinaryo mga citizens. Itong CPP and PNP. They're a terrorist group. Terorista sila. Alam mo pakiusapan mo yan? Mr. NPA, baka naman pwede kang sumuko kasi gobyerno kami, kailangan maging mapagpasensya kami. Kailangan, wala kaming karapatan maubusan ng pasensya eh. Nakakaloko ka naman dito, Senator. Bawat Pilipino, sumusunod man sa batas o hindi, bawat Pilipino na sumusuporta man o lumalaban sa gobyerno, sila pa rin ay mga constituents na dapat pinagsisilbihan ng ating pamahalaan. Ay, mali. Hindi ako agree dyan. Sorry, Senator. Sorry, Senator Cheese. Sorry. Hindi ako agree dyan. Pag pinili mo na ibagsak ang gobyerno, hindi ka na ordinaryong citizen. And you are no longer covered by the protections of the law kasi you chose to be a criminal. You chose to be a terrorist. So yung mga protection na afforded na ina-afford sa iyo ng batas, limitado na. Ang limitasyon na lang hindi na lang pwedeng gawin sa ng gobyerno, yung patayin ka without due process. Yun na lang, pero pwede kang i-detain, pwede kang hulihin, pwede kang tugisin, lahat pwedeng gawin sa'yo maliban sa patayin ka at i-torture. Yun ang bawal. Pero the government will have to do its best to apprehend every criminal, including not exempting those who are members of terrorist organizations. Mali, hindi ako naniniwala dito sa sinabi na ito ni Senator Cheese. Hindi ako naniniwala dito. Noong Nobyembre 23, naglabas ng joint communique sa pagitan ng gobyerno at NDFP kung saan inihayag ng dalawang partido na nagkasundo sila sa isang principled and peaceful resolution para tuldukan ang 54 years na armadong tunggalian sa bansa. Ayun, yun ang balita kanina kay Senator Cheese. Senator Cheese, reminder lang, no? May tanong lang ako sa'yo, Senator Cheese. Baka lang naman. Kasi meron din balita na lumabas. Ito yung pangalan ng balita. Ayan. Ay, good luck. Ba't nagkaroon ng good luck to? Wait, nasaan na? Ayun. Ayan. Ito yung title ng bago. CPP lays out demands to bolster peace negotiations between government and NDF. So sabi ng CPP, sige, makikipag-usap kami sa gobyerno pero dapat gawin nyo muna to. Sabi ng CPP. So ano yung hinihiling nila? Una, every time pinag-uusapan tong peace talks, lagi kong sinasabi to. Para lang ma-remind kayong mga pro-CPP, NPA, NDF. Hindi siguro, sige, let's give them the benefit of the doubt. Hindi naman siguro kayo pro-communist. Pro-peace talks na lang. So, let's be more accurate. Pro-peace talks. Lagi kong binabanggit to kapag merong mga politiko na nagsasabi na, hindi, sige, let's do peace talks tayo. Tulad si Martin Romualdez, tapos ito si Chis Escudero. Lagi ko itong binabanggit kasi ito yung demands ng CPP, NPA, NDF bago pa lamang mag-umpisa yung peace talks. Ibig sabihin, Hindi mag-uumpisa ang peace talks kung hindi ito gagawin ng gobyerno. Ano yung mga hinihingi nila? Una, tanggalin ang terrorist designation ng CPP, NPA, NDF. Bibigay niyo yan? Payag kayo dyan? Kayong mga pro peace talks? Payag kayo dyan? Tanggalin doon yung designation nila na teroristang grupo. Kahit na 54 years na silang nagte-terrorize sa kanayunan. Ayun yung una. Pangalawa, pangalawa, tanggalin ang NTF-ELCAC. Buwagin na yung NTF-ELCAC. By the way, mga kotsero, ang NTF-ELCAC is only an executive order. EO number 70 yan. Executive order yan ni Digong. That effectively created the National Task Force to end local communist armed conflict. Yung NTF-ELCAC. So it can be repealed anytime. Pwedeng tanggalin yan. Pwedeng tanggalin yan ng Presidente Bongbong. So yun ang pangalawang hiling. Tanggalin ang NTF. Okay. Pero take note mga kotsero, ang NTF-ELCAC, ito yung naging mekanismo para kumina ng sobra ang CPP-NPA. Nung walang NTF-ELCAC, malakas ang NPA. Nung nagka-NTF-ELCAC, within 3 years, kumina ang NPA. Actually, if there's any achievement ng Digong administration that really matters, dalawa lang naman eh. Yung infrastructure programs niya at saka yung NTF-ELCAC. That's it. Yung war on drugs niya, I think is a failure. It's a dismal failure, if I'm not mistaken. And that's how I look at it. It's a failure. Foreign relations niya is a failure. I would say. Pero kung meron man naging success ang Digong administration, that's it. Yung NTF-ELCAC at saka yung itong sa DOTR, sa DPWH. That's about it. So, ang gusto ng CPP, NPA, NDF, buwagin na itong NTF-ELCAC. Dahil sobrang successful eh. Ang dami naging rebel returnees, humina ang pwersa ng NPA. Now they are, meron lang doon silang 15 weekend fronts, weekend pa. 15 pero weekend pa. So, ibig sabihin, they're virtually gone. Ang estimates nga, by 2024, wala pa. That's the estimate. So gusto nila tanggalin yung NTF. Yun yung pangalawang demand. Pangatlong demand, mga kotsero, i-repeal ang anti-terror law. Tanggalin to yung anti-terror law. Constitutional yan, ha? Isang provision lang ng anti-terror law ang sinabi ng Supreme Court na unconstitutional. Isang provision. Pero dapat daw i-repeal. Kasi violation daw yun ng human rights. Really? Anti-terror law? Yung pagtigil sa mga terorista ay violation ng human rights. Bali-baliktad na talaga utak-utak nito mga komunista natin. Last, magpalaya ng 800 na quote-unquote political prisoners ng CBP, NPA, NPA. So, payag kayo dyan. Chis Escudero, payag ka. Doon sa 4, bigay natin yung 4. Gusto mo ng peace talks. Martin Romualdez, gusto mo ng peace talks, di ba? Bigay natin yun. Tanggalin na si NTF-ELCAC, tsaka repeal natin anti-terror law. Yun yung pinakamabigat actually. Kasi yun, institutional yun. Yung tanggalin yung terrorist designation, it's a product of the anti-terror law. Tapos yung political prisoners, quote-unquote, produkto din yun ng anti-terror law. So really, kapag ni-repeal mo yung anti-terror law, edi tanggal na lahat yun. Game? Yun yata yung dumaming terorista sa Pilipinas. Baka yun yung gusto nyo. Baka nakakalimutan nyo na may kakabombing lang dyan sa Mindanao State University. At ang gumawa Duwala Islamiyah. Terrorist group. Baka lang nakalimutan. Tapos gusto nyo ng peace talk sa mga Reds kung kailan mahina na sila. Gusto nyo baguhin ang sistema. Yan. O ganun. Alam naman natin kung ba't nagkakampihan ngayon ng mga kongresista eh. Diba? You made a deal with the devil eh. Si Martin Romales made a deal with the devil. So, ngayon, kating-kating ngayon ng take advantage excuse me. Take advantage ngayon yan ng mga makabayan black. Sinong mahihirapan ulit? Tayong lahat na ordinaryong Pilipino na lumalaban ng patas, bibiktimahin lang na naman tayo ng kung sino-sinong miyembro ng teroristang grupo. Sana hindi matuloy itong peace talks. And by the way mga kutsero, lilinawin ko lang. Kung sinabi ni VP Sara, dalawang aspeto yan. Isang amnesty, isang peace talk. Yun yung kinontra niya pareho. Ulitin ko lang para lang malinaw kasi parang every video ko nakakalimutan yung decision ko sa mga issues. Ulitin ko lang. Sa amnesty, disagree ako kay VP Sara. 100% I disagree with VP Sara doon sa aspeto ng amnesty. Again, because sa amnesty it's a benefit that you give to rebel surrenderies, mga sumuko. Dahil na-realize nila yung pagkakamali nila, that's what you give them, amnesty. Binigay din niya ng previous administration, kaya yung mga DDS na makulit dyan, awayin nyo rin si Digong. Kung gusto nyo awayin si Presidente, awayin nyo rin si Digong kasi tinuloy lang ni Bongbong yung ginawa ni Digong. So, ganun. Sa amnesty. Sa aspeto naman ng peace talks, yan, disagree ako dyan. Sa aspeto ng peace talks. Dapat wala na yung peace talks. Kasi alam naman natin na ang peace talks ginagamit lang ng CDP-NPA para magpalakas ng pwersa. Pero kung ang peace talks na gagawin nila walang ceasefire, most probably mas katanggap-tanggap yun sa majority ng Filipinos. Yung walang ceasefire. Kasi pag may ceasefire, doon nagpapalakas ang CPP-NPA. Pag may ceasefire. So, most probably mas katanggap-tanggap yun, yung walang ceasefire. But overall, I think majority ng Filipinos disagree with the peace talks. Majority. Lalo na yung mga naging biktima ng CPP, NPA, NDF. So please lang, wag na natin ipilit. Kung ayaw ng tao, ba't nyo pinipilit? Ba't kayo yung makulit? Kaya nga kayo nandyan dahil sa taong bayan, tapos kukontrahin nyo yung gusto ng taong bayan, di ba? Ano pang ginagawa nyo dyan? Ano pang silbi nyo? Ba't kayo nandyan? So, anyway, hanggang dito na po muna tayo sa video na ito. Maraming pong salamat sa inyong patuloy na pagsuporta sa ating channel. Please don't forget to subscribe to our Coach Reality YouTube channel at sa ating Facebook page, and I'll see all of you in our next live stream coming soon pagkatapos ng klase ko, and I'll see all of you there mga kochero. God bless everyone and see you next time. Bye!
Curiosity stumbles upon an ancient stream bed, takes some spooky images during the night, and finds bright particles on the Martian surface. August 6, 2012. The Mars Reconnaissance Orbiter happens to be in the right place at the right time to capture this incredible image of the Curiosity rover parachuting onto the surface of Mars. After a nerve-wracking but successful landing, Curiosity opens its eyes. It will eventually start to climb the mountain in the distance, which is informally known as Mount Sharp. For now, however, the rover will drive away from Mount Sharp towards an interesting region known as Glenelg. Just 13 Martian days into the mission, or Sol 13, Curiosity examines a site that was blasted by the engines of its descent stage. Nicknamed Goulburn Scour, these sedimentary rocks are thought to have been laid down by running water in the ancient past, and uncovered by the descent stage as it blasted away the surface dust. On Sol 16, Curiosity takes a close look at the layers which form the base of Mount Sharp, with scientists theorizing that these layers could be another clue of a watery past. On Sol 27, Curiosity comes across a site which again could be linked to running water. This image shows what is known as a sedimentary conglomerate, a geological formation that is created by streams or rivers here on Earth. The engineers at NASA check the health of Curiosity's wheels. They look to be holding up pretty well so far. On Sol 39, the rover comes across yet more evidence of a Martian stream. This is a piece of exposed bedrock, made up of small segments cemented together. This is likely evidence of ancient water due to the rounded elements of the bedrock itself, as well as the round rocks and pebbles surrounding it. It's possible these rounded rocks were transported and deposited here by running water. If finding 3 sites likely formed by running water wasn't enough evidence, just look at how they are arranged. The yellow arrows at each site depict the direction of the ancient stream. While this map shows the route the rover has taken so far, Curiosity turns around to once again take in the sight of the mighty Mount Sharp in this incredible mosaic. Climbing the mountain will be hard, but worth it in the end. Curiosity comes across an interesting pyramid-shaped rock and decides it's a good time to test out its onboard laser. In this image, the dots are where Curiosity trained its laser, and the results are unlike anything yet seen on Mars. The rock has a mineral diversity down to the finest scales and is very similar to a rare but widespread rock type found on Earth. On the road to Glen Elg, a site known as Rock Nest is selected for the first use of Curiosity's scoop. The patch of sand downhill from the cluster of dark rocks should make for a great scoop sample. At the site, the rover comes across an interesting rock. It's not clear what has caused the thin cavities present in the rock. On Sol 61, Curiosity makes its first scoop. Darker colored sand is exposed just beneath the surface. The sample will now be shaken and put through a filter. This series of images shows the shaking operation. This makes sure that the sample scoop is not overflowing with material and allows the scoop to be sealed shut. This image shows the filter. After the shaking operation, any particles too big to pass through this filter are transferred back to the scoop for a visual inspection. Those larger particles can be seen here. This first sample will not be fully processed, as its presence in the scoop helps to further decontaminate all the surfaces coming into direct contact with future samples. On Sol 65, the team at NASA spots an interesting piece of debris on the Martian surface, just next to the rover. This close-up confirms it is likely to be from the spacecraft, possibly as a result of the landing. It is likely a benign piece of plastic or shrink tube left over from a terminated piece of wire. As Curiosity takes its second scoop, a bright particle can be seen in the sample hole. Given that spacecraft debris has been identified in the area, the team at NASA orders the rover to also discard the second sample. If any of these bright particles are from the spacecraft and are subsequently fed into the internal sampling unit, the rover could become contaminated with bacteria from Earth. However, upon further inspection and analysis, more bright particles are spotted on the ground, and the team now believes these are native to the Martian soil. It is likely these bright particles are made up of silica or some other naturally occurring mineral. With this knowledge, the rover goes ahead and takes its third scoop, which is fully processed. The result of the soil sample shows that about 2% of the material collected is made up of water. The rover exposes the sample to heat. Carbon dioxide, oxygen, and sulfur compounds are released. To celebrate, the rover takes a little break from sampling and captures this stunning panorama of the Rock Nest area. Curiosity will continue on to Glen Elg. On Sol 120, the rover comes across a site nicknamed Shaler. The Shaler outcrop is dramatically layered, once again signaling the presence of water in the ancient past. This part in particular, known as sheepbed locality, shows well-defined veins filled with a whitish material likely to be calcium sulfate. The rover reaches a wider area known as Yellowknife Bay and takes a look around. In this annotated image, the white arrows represent mineral veins and the black arrows represent mineral concretions. Both veins and concretions are strong indicators of mineral precipitation from water. A target is chosen for the first use of Curiosity's drill, a drilling site known as John Klein. This flat, hard bedrock should provide an ideal testing ground. As the engineers at NASA prepare for the first drill, Curiosity spots a small, broken rock, nicknamed Tintina. Curiosity deploys its mast cam to perform a spectra analysis and produces a mineral hydration map. The results show the inside of the rock is much more hydrated than the outside. The team orders Curiosity to pull an all-nighter. These are the first nighttime images from the surface of Mars. The team wants to see what the rocks look like under UV lighting, to see if any fluorescent minerals are present. Unfortunately, this image taken under UV lighting doesn't show much evidence for fluorescent minerals. If they were present, we would see bright red, blue, or orange areas. On Sol 174, Curiosity breaks a rock in half by driving over it. A happy accident. Curiosity's clumsiness reveals a very bright substance within the rock. This is probably caused by the presence of silicon, commonly found on Mars. Curiosity takes a selfie before its big drill test at the John Klein site. The drilling goes ahead and is a great success. The drill sample is transferred to the scoop, which will feed the sample into Curiosity's internal sampling system. On Sol 200, Curiosity stops responding to commands. Engineers fear Curiosity is stuck in a boot loop, which will cause the rover to drain its battery and be unable to function. Luckily, Curiosity has two computers on board for such a problem, Side A and Side B, or pilot and co-pilot. The rover is programmed to switch to the co-pilot automatically if the pilot malfunctions. However, the pilot has other plans and does not cede control to the co-pilot. The engineers are worried that the pilot could shut off the radio at any moment, and they would never hear from the rover again. They decide to take a risky move and shut down the pilot, hoping that the co-pilot will then step in and take over. After shutting down the pilot, the team waits to hear a signal from the co-pilot, which should happen right away. 1 minute passes, no signal. 4 minutes pass, still no signal. Then finally, the signal comes in, and it's clear that the co-pilot is now in charge. Curiosity can breathe a sigh of relief and continue with operations. Now that the rover has switched over to the B side, the team must check all the systems once again. Now that everything is working as intended, Curiosity takes a long drive. This image, taken on Sol 343, shows the road before Curiosity. The two gray rocks in the center are nicknamed Twin Cairns. Curiosity sees a mysterious light on the horizon, spots Earth in the sky, and crosses Dingo Gap, a perilous sand dune. Curiosity is now en route towards the central peak of Gale Crater. To make the journey easier, Curiosity has the ability to drive itself with no help from anyone on Earth. This enables faster progress, which means Curiosity is already closing in on an area dubbed Darwin. The light-toned streaks in the lower left center of the image mark the position of the outcrop that scientists want to examine. Curiosity takes another look at the layering making up the base of Mount Sharp from its new vantage point. This area looks particularly exciting and is named Pahrump Hills. The team hopes to explore this area soon. On Sol 400, Curiosity examines the Darwin outcrop with its Mars Hand Lens Imager, or MALI for short. This 4-image mosaic shows a ridge, formed when a crack in the underlying sandstone which was filled with a material that then eroded more slowly than the rock itself. Note the Lincoln penny at the bottom left, Molly's own unique calibration target for scale. While studying this rock named Ithaca, the rover's ChemCam laser is fired for the 100,000th time on the Martian surface. The arrows point to the dark spots left by 10 different laser shots. Analysis shows Ithaca to be a typical Martian volcanic rock type. As Curiosity reaches nearly 3 miles of driving, life on Mars begins to take its toll. Further computer glitches are followed by a loss of power, which temporarily strands the rover. This is tracked down to an intermittent short in the RTG, Curiosity's nuclear power source. At the same time, an even more serious issue arises. A routine scan of the rover's wheels on Sol 469 shows unexpectedly heavy damage. According to Jim Erickson, Curiosity project manager, we always expected we would get some holes in the wheels as we drove. It's just the magnitude of what we're seeing that was the surprise. Concerned, the team modifies Curiosity's planned route, trying to drive on smoother, sandier terrain. The trip to Mount Sharp will be longer, but hopefully safer for the rover. As part of the new route, Curiosity comes across a target named Harrison, which contains light-colored elongated crystals, most likely a mineral known as feldspar. Analysis using ChemCam shows the darker matrix material to be pyroxene, a mineral typically found in basaltic igneous rocks. On Sol 526, Curiosity faces another challenge. The modified route to Mount Sharp means crossing this sand dune, known as Dingo Gap. It will open the way to smoother terrain, which should be easier on the rover's battered wheels. But there's a danger the rover could become permanently trapped, like Spirit, its predecessor on Mars. While the engineers at NASA prepare to cross Dingo Gap, Curiosity is stargazing. Just after sunset, the rover captures a Martian evening star, otherwise known as Planet Earth. Look closely and it's possible to see our moon too. On Sol 535, Curiosity begins to cross Dingo Gap. As this view from the rear hazard avoidance camera shows, with 6x6 drive, a little off-roading proves no problem at all for Curiosity. Curiosity looks back at its tracks across the perilous gap. To give you an idea of scale, the distance between the parallel tracks is about 9 feet, or 2.7 meters. After crossing the gap, Curiosity makes good progress and is aiming for an area named Kimberly. On the approach to Kimberly, Curiosity spots these sandstone beds, tilted down toward Mount Sharp from the rim of Gale Crater. The team interprets these layers as deposits from deltas flowing down from the rim into a small lake that once covered the center of the crater. It's a pattern that's repeated throughout the area. On Sol 589, Curiosity captures something that shocks scientists: a glowing light in the distance. The bright light puzzles scientists. Possible explanations could be a cosmic ray hit on the camera, or something as simple as sunlight glinting off a rock. But unless Martians wear tinfoil hats, it probably isn't our first sighting of aliens. The most likely explanation is a cosmic ray hitting the camera. Cosmic rays are high-energy particles that fly through space. This is the most likely explanation, because another image was taken with a different camera at the exact same time, which did not capture the strange anomaly, or in other words, wasn't hit by that same cosmic ray. Even astronauts working in space have reported seeing strange flashes of light with their own eyes, which are also believed to be cosmic ray hits. When a cosmic ray passes through the retina, it causes the eye's rods and cones to fire, and the eye perceives a flash of light that is really not there. Thankfully, here on Earth, we are protected from cosmic rays by our magnetosphere. However, Mars has a much weaker magnetic field. Future Martian settlers may just have to accept and deal with strange pseudo-lights caused by cosmic ray hits. With so much great science, investigations at Kimberly continue for some time. This image taken on Sol 590 shows the same build-out of ancient sediment towards the base of Mount Sharp, with the mountain itself towards the left of the scene. Also, a small hill can be seen in the midground. So clear are the different layers of rock that the team dubs this site Mount Remarkable. On Sol 597, NASA's Mars Reconnaissance Orbiter is flying overhead and manages to capture Curiosity near the Kimberley site. Can you spot the rover? On Sol 609, Curiosity arrives at a rock slab that scientists called Winjana. The 2-foot-wide rock looks like a perfect target for Curiosity's drill. As these before and after shots show, an area of the rock around 6 centimeters across is scrubbed using the dust removal tool, followed by test drilling to a depth of around 2 centimeters, and a full-sized test hole. The series of dark dots which are visible inside the hole were created by Curiosity's ChemCam laser. The samples obtained are examined by several of Curiosity's onboard scientific test instruments. The results are analyzed by researchers back on Earth and point to the likelihood that flowing water was once prevalent in the area. Pleased with its work around Kimberley, Curiosity poses for a selfie. On Sol 648, Curiosity is looking at the sun and manages to capture something remarkable, an object crossing its field of view. This object is actually the planet Mercury, and it's the first time a planetary transit has been witnessed on a planet other than Earth. As this map shows, by Sol 705, the rover is well on its way toward the Pahrump Hills at the bottom left. The new route designed to make the journey easier on Curiosity's wheels will take the rover through a valley aptly named Hidden Valley. However, this new soft-sanded route doesn't come without problems. After driving only a short distance into the valley, the rover's wheels seem to be slipping on the ground, and the team starts to worry that the rover may become stuck. Rover planners decide it's too risky to continue, and so order Curiosity to leave the valley and head back to more stable ground. Curiosity escapes Hidden Valley, explores a site named Garden City, and witnesses the Martian sunset. The rover is currently located in a valley with soft, deep, and slippery sand. The team at NASA wants to get out of the valley as soon as possible, as Curiosity could become stuck. This series of images from the rear HazCam shows the rover backing out of the valley, retracing its tracks. This is the view from the other side of the rover, the front HazCam, as the team initially sent the rover in backwards, a strategy used to compensate for the poor health of Curiosity's wheels. Now, safely out of Hidden Valley, Curiosity is finally approaching the Pahrump Hills. The team decides to take a drill sample at this site, known as Confidence Hills, as the rocks nearer to Mount Sharp will help to develop a picture of what happened in this area. Here is the sample in the scoop. On Sol 801, the team decides to perform an experiment by driving over a sand ripple to expose the material below. The reason for this experiment is to gain a better understanding of the loose, wind-deposited sand ripples in the area. Hopefully, more knowledge about these deposits will prevent future situations like the one at Hidden Valley. The wheel track provides a cross-section view of the sand deposit, and Curiosity uses its laser to take data. On Sol 817, Curiosity comes across some interesting exposed bedrock and takes a close look. The area is about 6 feet or 2 meters across. Meanwhile, the Mars Reconnaissance Orbiter is flying overhead and spots the rover, now squarely within the Pahrump Hills area. Curiosity is ordered to perform a drill test on a target named Mojave. The result is a cracked rock. On Earth, geologists carry hammers to crack rocks. This apparent mishap presents a rare opportunity to see freshly exposed rock on the Martian surface. Curiosity is ordered to take 2 drill samples from the same site. No further cracking is observed. The rover celebrates by taking a selfie. This map shows an area named Artist's Drive, which Curiosity will have to pass to access higher rock layers on Mount Sharp. On the way, the team at NASA spots an interesting outcrop, which is named Garden City. Exposed mineral veins crisscross the entire area. Curiosity heads over to take a closer look. Mineral veins usually form where fluids move through fractured rocks, depositing minerals in the fractures. In this case, the minerals deposited in these veins have been more resistant to erosion than the surrounding host rock. The contrast between the light veins and darker rock type here suggests a very high fluid pressure. This image covers an area roughly 2 feet or 60 centimeters across. The Mars Reconnaissance Orbiter spots the rover once again within the Artist's Drive site. Can you spot it? This interactive map made by NASA shows the true scale of the journey. Zooming out from the Pahrump Hills area, we can see the size of Gale Crater, as well as Mount Sharp in the center. Gale Crater is roughly 96 miles in diameter, or 154 kilometers. Curiosity stops to take a panorama within Artist's Drive, now well within the Pahrump Hills region. This mosaic shows the view in front of the rover. Gravel and sand ripples can be observed in the foreground, typical of terrains that Curiosity traversed to reach Mount Sharp from its landing site. Outcrops in the midfield are of two types: dust-covered, smooth bedrock that forms the base of the mountain, and sandstone ridges that shed boulders as they erode. Rounded buttes in the distance contain sulfate minerals, perhaps indicating a change in the availability of water when they were formed. On Sol 956, Curiosity captures multiple images of the Martian sunset. This short series of images provides the most detailed view of what a sunset looks like on Mars. As Curiosity continues, it approaches an area nicknamed Logan Pass. This closer image shows that this terrain is unfavorable for the rover. Instead, the team decides to take Curiosity through a safer passage known as Marias Pass. On its way through, Curiosity observes what scientists are calling the Stimson Unit. These dark areas of finely bedded sedimentary rock are found throughout Gale Crater and make up the Stimson Unit. Here, the lighter-colored mudstone is intersecting below the Stimson Unit, leading the team to conclude that the mudstone was created first, and then a large body of water-deposited minerals that make up the layers of the Stimson Unit. This image of another contact zone at Marias Pass, nicknamed Missoula, lends further credence to this theory, as the white mineral veins abruptly end where they meet the darker rock above. So firstly, the mudstone would have hardened, then fractured, and then groundwater-deposited minerals to form these veins. Sometime after that, large bodies of water made the layers visible at the top. Just a few days later, on Sol 1041, Curiosity comes across another interesting rock, which is thought to have been formed by the wind and contains a large amount of silica. Rocks containing silica are known to be exceptionally good indicators of ideal conditions for preserving ancient organic material. The team at NASA orders Curiosity to examine the health of its wheels. During this process, a rock can be seen hitching a ride inside one of the wheels. The rock should prove to be no danger to the mission and will eventually fall out on its own. Although showing a lot of damage, as well as some rather large holes, the wheels are okay for now. The rover is ordered to take a rock sample from a site known as Buckskin and celebrates by taking yet another selfie. Curiosity explores a giant dune field, takes some stunning images, and approaches the entrance to Murray Buttes. Still squarely within the Pahrump Hills region, Curiosity finds more evidence of cross-bedding. Due to the angles of these layers, it's more likely they were created by wind rather than water. On Sol 1099, the rover looks toward its main objective, Mount Sharp. The lighter-colored rocks in the distance are the oldest in this image and have been heavily eroded by the wind. A large portion of the other rock variations present are thought to have been formed by water. While looking for the best way to get up the mountain, the Mars Reconnaissance Orbiter spots a huge dune field. The team at NASA decides to send the rover to investigate. From its current position, Curiosity can see part of this dune field, the dark band in the midground. The team at NASA gives it the informal nickname, the Bagnold Dunes, named after Ralph Bagnold, who crossed the Libyan desert and was one of the first explorers to acquire a deep understanding of the physics behind sand dunes. In this map, we can see the true scale of the Bagnold Dunes. Curiosity will explore only a small portion of it. As the rover moves closer, it captures this stunning image, with Mount Sharp looming in the distance. But first, Curiosity has some drilling to do at a site named Big Sky. The rover takes a selfie in celebration of a successful drill. On Sol 1176, Curiosity reaches the edge of the dune field. This is the first active dune system studied up close on another planet. Scientists observing the dunes estimate they are migrating by about 1 meter per year due to action from the Martian wind. The rover carefully dips a wheel into the sand. This close-up image of the dune portion disturbed by the wheel shows finer grains of sand below the surface. This close-up shows an undisturbed portion of the dune. We can see that only coarse surface material remains, after wind action has removed the smaller particles. On Sol 1197, Curiosity comes across a very steep dune which the team names Namib Dune. The thing which differentiates dunes from the usual sand deposits, such as those the rover was nearly stuck in at Hidden Valley, is that dunes are steep enough on their downward face that material can actually fall down the side of the dune. Curiosity takes a sample of sand from near the Namib Dune site and takes a selfie to celebrate. The coarse material from the sample, which was too large to fit through the rover's filter, is dumped onto the ground. The team waits until nightfall to take an image of the dumped material with artificial lighting. This lighting makes it easier to differentiate between the darker and lighter grains. Curiosity continues the journey up the base of Mount Sharp, reaching a site known as Nowclift Plateau. On Sol 1276, Curiosity comes across some knobbly textured sandstone within Nowclift Plateau. These nodules seem to be more resistant to wind exposure than the surrounding host rock. It's the first time Curiosity has come across this type of pattern in Gale Crater, but it has been spotted by previous rovers on Mars. It's likely these are what the team at NASA refers to as blueberries and are made up of a mineral known as hematite, which suggests the presence of water in the ancient past. From its position within Nowclift Plateau, the rover takes a long-distance image of the northern rim of Gale Crater. The image is taken during sunrise, when dust in the atmosphere is relatively low. On the lower portion of the crater rim, we can see valleys, channels, and debris fans, much like what we currently see at the base of Mount Sharp. This leads scientists to expect that the entire crater was once filled with water. Curiosity takes a full-circle panorama at Nowcliff Plateau. The rocks present here are dominated by thick layers of wind-blown sand, suggesting that these deposits formed during a drier time on Mars. On Sol 1315, NASA orders the rover to complete a wheel health check. Since the last wheel check, nearly 300 sols ago, little further damage is observed, meaning that the rover planners are doing a great job of selecting easier terrain for Curiosity. As Curiosity comes close to completing 4 Earth years on Mars, it hits a milestone of 2 Martian years studying the planet. During this time, Curiosity has been studying Martian seasonal patterns. As you can see from the graph, Mars is much colder than Los Angeles. The height of the bars represents the temperature difference between night and day. During the summertime in Gale Crater, daytime temperatures can reach a survivable -10 degrees Celsius or 14 degrees Fahrenheit. However, on the very same night, temperatures could drop all the way to -70 degrees Celsius or -94 degrees Fahrenheit. Curiosity also takes measurements of atmospheric pressure. This data will prove to be extremely useful if NASA ever wanted to send a helicopter to accompany a future rover. The rover takes a drill sample at Nowcliff Plateau and looks toward Mount Sharp. We can also see some leftover rock powder, the gray substance on the surface, dumped by the rover after it did not pass through the filter. After a big drive, Curiosity arrives at the gates of a site known as Murray Buttes. Curiosity will pass through here to access higher areas of Mount Sharp. Curiosity explores some giant mesas, finds a Martian meteorite, and captures multiple dust devils. Curiosity is closing in on the Murray Butte site, informally named after planetary scientist Bruce Murray, who was a former director of NASA's Jet Propulsion Lab in Pasadena, California. The 2 most prominent mesas in this image are about 260 feet or 80 meters apart. The mesas are about 33 feet or 10 meters high. The buttes and mesas here are thought to be eroded remnants of ancient sandstone created by wind-blown sand after lower Mount Sharp had formed. They are capped with material that is relatively resistant to erosion, giving them a top-heavy appearance, as is the case with many buttes and mesas here on Earth. The rover gets a view from a different position. The relatively flat foreground is part of what scientists are calling the Murray Formation, which includes ancient lakebed mud deposits. We've seen this formation in previous episodes and examined how it interacts with the Stimson unit, made up of darker layered deposits. Curiosity moves closer to one of the buttes, which is given the affectionate nickname Butte M9A. It stands at about 16 feet or 5 meters above Curiosity. On the left side of the butte, the average slope is estimated to be at about 40 degrees, while the right side is less steep at about 30 degrees. The rover takes a step back to get yet another view of this scenic area. It will now pass through the buttes. The rover takes 5 incredible close-up images on its way through. The thin layers here are evidence that this area was created by wind action and sand dunes. This is known as cross-bedding. The angles of some of the layers also give this indication, as water-based deposits tend to be more level. Now, almost safely through the buttes, Curiosity takes a drill sample and celebrates by, you guessed it, taking another selfie. On Sol 1505, Curiosity comes across a very strange rock. Using its laser, the rover confirms the rock to be an iron-nickel meteorite. The shiny white spots you can see on the rock are due to the laser pulses, and the meteorite is around the size of a golf ball. Curiosity looks toward the higher elevations of Mount Sharp. These annotations give a sense of distance and scale. On Sol 1555, the rover stumbles upon a portion of the Murray Mudstone Formation, which shows what could possibly be ancient fossilized mud. This small grid of polygons could have originated as cracks in drying mud over 3 billion years ago. The area is given the nickname Squid Cove. The polygons are around 1 to 2 centimeters or half an inch to an inch long. Another rock slab in the area showing the same type of pattern is observed. It's given the nickname Old Soaker. Curiosity drives to get a closer look. This pattern would have been created by a 3-step process after ancient Martian mud dried out, causing it to crack. First, wind-blown sediments filled the cracks. Second, the sediments and mud became rock under the pressure of younger layers accumulating above them. Lastly, after the younger layers were removed by the wind, the sedimentary areas remained, being more resistant to erosion than the mud, causing them to appear as ridges now instead of the cracks they originated as. On Sol 1587, Curiosity takes a break from driving. The team picks up the next day where they left off and sees that the sand beneath the rover has moved. This constant action from the wind is responsible for a lot of the rock formations and dunes we've seen so far. The area pictured beneath the rover is around 3 feet or 1 meter across. It's summertime in Gale Crater, and Curiosity spends the next few days observing dust devils. These dust devils are created by the sun heating up the surface, causing convection currents as hot air rises, carrying dust with it. They are most active in the Martian summer, as they are here on Earth. In this recording, we can see the dust devil disappear over a hill in the distance. In reality, the dust devils are moving much slower, as the images making up this sequence were taken in intervals of 12 seconds. On Sol 1598, Curiosity reaches a strange-looking hill. It's given the nickname Ireson Hill and stands about 16 feet or 5 meters high. Nearby is a large dune field. It's given the informal name Nathan Bridges Dune, in memory of the planetary scientist Nathan Bridges, who was leading the Curiosity team's dune campaign. On Sol 1641, a wheel check shows a break in the raised tread on one of Curiosity's wheels. These raised treads are called grousers, and testing with identical wheels on Earth shows that when 3 grousers have broken in any one wheel, the wheel has reached around 60% of its useful lifespan. Fortunately, the slow rate at which the grouser's condition is deteriorating means Curiosity can continue for quite some time. Other images taken during the wheel check show a slight increase in the number and the size of holes present. On Sol 1647, the team spots part of an active sand dune that contains features not seen back here on Earth. The dark crested ripples are several feet apart, and this particular mix of medium-scale ripples, along with the smaller scale ripples, are, as far as we know, unique to Mars. The area is given the nickname Ogunquit Beach. Curiosity's planned route will take it over a large ridge, known as Vera Rubin Ridge. The mineral hematite had been identified on this ridge by the Mars Reconnaissance Orbiter, well before Curiosity's landing, and it has always remained a target of interest. The rover is now approaching the ridge. As Curiosity gets closer, the layered deposits making up the ridge become clearer. The rover will now begin to climb up the ridge. As this map drawn up on Sol 1750 shows, the Vera Rubin Ridge climb will give Curiosity access to special areas higher up Mount Sharp, such as the clay and sulfate units. The yellow line beyond Vera Rubin Ridge shows the proposed route. As the 5th year of Curiosity's mission draws to a close, the rover is watching out for Martian clouds. The 8 images in this sequence were taken over a span of 4 minutes. The clouds are similar to cirrus clouds on Earth, likely composed of crystals of water ice which condense onto dust particles in the thin Martian atmosphere. Curiosity climbs up Vera Rubin Ridge, finds what some scientists believe to be fossils, and survives a global dust storm that permanently incapacitates another NASA rover.
Magkaiba man tayo. Bagay pa rin. Opposites do attract. Yeah, what are you waiting for? Take a chance and make a move with Cornetto. Stream Love You Very Much on Spotify.
You may have noticed that Curiosity hasn't taken a drill sample for quite some time. This is because the last time the rover attempted this in December of 2016, a key part of the drill stopped working. The rover arm was originally designed with 2 finger-like stabilizers within which the drill bit extends and retracts. A faulty motor stopped the drill extending past the stabilizers, and the team has been looking for a fix ever since. On Sol 1780, the team at NASA manages to get the drill out to its fullest extension, 110 millimeters, and now plans to bypass using the stabilizers altogether. This would be similar to freehand drilling, such as when people drill into the walls of their homes. This new technique is named feed extended drilling, and NASA scientists will have to hack into the rover's other capabilities, such as pressure sensors on the rover's arm, to be able to do this successfully and safely. Curiosity is approaching Vera Rubin Ridge. The horizontal stratification of the rock, coupled with the crisscrossing white veins, are indicators of fluid flow through the rock. This ridge will make a great target to test the new drilling method. The rover edges closer. The team at NASA decides to deploy Curiosity's dust removal tool on a nearby rock. First, the dust removal tool is inspected for damage. The wire bristles are spun at 10,000 revolutions per minute for a duration of around 60 seconds when removing dust. The wire bristles seem to be holding up well, and the rover is ordered to proceed. The brushed area is around 2.5 inches or 6 centimeters across. The purple tint signals the presence of hematite. The area is nicknamed Christmas Cove. When applying Curiosity's science camera filters, the presence of purple-toned hematite is undeniable, signaling the presence of water in the past. The white veins are believed to be calcium sulfate minerals, also caused by the flow of water. On Sol 1856, the rover reaches the top of Vera Rubin Ridge. The view from here is incredible. The slopes in the distance make up the northern wall of Gale Crater, and Curiosity's landing site is also visible. The rover is really starting to gain some elevation as it heads up Mount Sharp. At the top of Vera Rubin Ridge, the rover comes across some strange stick-shaped features. They're about 5 to 10 millimeters long, or about the size of a grain of rice. Some scientists believe these could be ichnofossils, a record of biological activity in the past, but not direct fossilized remains of an animal or plant. They argue that nothing like this has ever been seen on Mars before. They are concentrated in this area, and they resemble trace fossil burrows back here on Earth. What makes this even more compelling is that Vera Rubin Ridge could very well have been an ancient shoreline. The rover planning team gives Curiosity some more time to investigate with its ChemCam instrument. However, it fails to gather any usable data. NASA believes these features are simply fracture fills that are more resistant to erosion, which have broken up to create these small, dark sticks. What do you think? Leave your theories in the comments below. Curiosity comes across a staircase-like feature atop Vera Rubin Ridge. The layering of the rocks up here really interests the team at NASA. The rover turns its focus towards Mount Sharp. The area in the midground is believed to contain large amounts of clay. This map shows the journey thus far. The rover has made it over the Bagnall Dunes, up onto Vera Rubin Ridge, and is making good progress up the base of the mountain. Curiosity takes a selfie at its current location on Vera Rubin Ridge. The team at NASA wants to test the new drilling technique here. On Sol 1956, the rover performs a partially successful drill using the new so-called freehand method. At just 2 centimeters, the depth isn't enough to enable Curiosity to process the sample, but it's a step in the right direction. On Sol 2057, the team orders Curiosity to attempt another drill at a site named Duluth. This time, at a depth of 2 inches or 5 centimeters, the drilling is a complete success. This is the first drill sample taken in over a year, and the team at NASA is ecstatic. Curiosity's drill is back online, and this proves that the new technique, feed extended drilling, can and does work. While the rover is happy with its success, the Mars Reconnaissance Orbiter is circling the planet overhead and detects a dust storm starting to grow in size. The sample is transferred successfully into the sample inlet using a slightly different technique, aptly named the Feed Extended Sample Transfer, to the now permanently extended position of the drill. On Sol 2074, the Mars Reconnaissance Orbiter reports that the dust storm is growing significantly in size and intensity, covering the whole planet. This series of images shows how the storm has grown. This image shows what the face of the planet now looks like. You can see huge swirls of dust almost covering the entire planet. This is Curiosity's view of the storm. The image on the left was taken just 3 sols ago. Curiosity wants to celebrate a successful drill in its usual way, by taking a selfie. So it does, even if it is a little bit dusty out there. Luckily for Curiosity, it has a nuclear power source and doesn't rely on solar panels, unlike some of NASA's previous rovers. One such rover, Opportunity, is currently exploring the other side of the planet and has been doing so for the past 14 years. Unfortunately, this is the last picture NASA received from the Opportunity rover. After 14.5 years of continuous, faithful service, Opportunity stopped responding and went into hibernation. The dust covered its solar panels and the rover was unable to generate enough power to keep itself warm at night. Most of its components are thought to have been frozen and irreversibly damaged. It's unlikely the rover will ever come back online. As the storm begins to subside, the now lonely Curiosity rover takes another snap of the Duluth drill site. These 2 images show the site before and after the storm. Curiosity takes a quick picture of its drill to check for any damage from the new drilling method. All seems to be holding up well so far. Curiosity has an issue with its memory, stares at clouds in the sky, and witnesses a Martian eclipse. Curiosity is still in the lower Vera Rubin Ridge area, at an important place called Pettigrove Point. The rover has been drilling at this spot for a long time, but has failed to reach the desired depth, Sadly, the rock is too hard to penetrate. Incidents like this cost a lot of time and energy. Going forward, the engineers at NASA decide to drill only at spots that meet two criteria. One, did the surface scratch the bristles of the dust remover tool? And two, are the calcium sulfate veins properly exposed after brushing? If it's a yes to both these questions, it's a strong signal for the rover to attempt a drill sample. The next day, on Sol 2122, the rover attempts again, this time at a place called Ailsa Craig. As a test, the dust removal tool tries to brush off the top sediments. Again, the drilling is a disaster. Despite the veins being somewhat exposed, the drill hole isn't deep enough for a full sample. This is now 2 unsuccessful drill attempts back to back. On Sol 2136, the team orders the rover to try drilling one last time at Pettigrove Point, at a site called Store. Store checks both the boxes. The brush bristles are slightly battered and the veins of the rock are adequately exposed. Finally, the rover succeeds in drilling a 46-millimeter deep hole. This hole has produced enough rock powder to be fed as a sample to the rover's onboard laboratory. Before packing up, Curiosity takes several observations with its ChemCam and MassCam and sends the data back to Earth for analysis. If the wind subsides, the rover will drop the samples onto its lab inlet. Pleased with its work around Vera Rubin Ridge, Curiosity takes a panorama. The sky is still hazy from the subsiding global dust storm, and a layer of dust can be seen on the rover itself. On Sol 2138, Curiosity captures an image that surprises the team. A small object is seen that looks completely different from the surrounding terrain. It's immediately labeled as foreign object debris and raises an alarm throughout the scientific community. While everyone speculates that this could be spacecraft debris or worse, a piece of Curiosity itself, the rover's ChemCam results, however, dismiss both. It is nothing but a thin flake of Martian rock. On Sol 2172, Curiosity suddenly stops sending a big chunk of its data to Earth. It can only send data when it is connected live to the Earth stations or the Mars orbiters. The team at NASA believes Curiosity has a problem with its memory. The rover normally stores data on board until it reconnects with Earth or Mars relay orbiters. Then it offloads all its precious stored data. The rover is currently failing to store anything. Due to the limited information coming from the rover, the team struggles to diagnose the issue. Luckily, Curiosity has 2 computers on board, Side A and Side B. However, if you remember, the team has already switched over to the B side due to corrupted memory on the A side, almost 2,000 sols ago. They make the drastic decision to return to the A side. It has much less memory than the B side had when it worked correctly, but it will help them to diagnose the issue faster and hopefully lead to an eventual return to the B side once a fix has been found. Curiosity resumes operations from its A-side computer, taking this panorama at a location known as Rock Hall. The rover also takes a selfie here after a successful drill sample. The area is still covered in dust after the global dust storm that incapacitated the Opportunity rover. Curiosity is now moving towards a clay-rich area that scientists have been hoping to see for the last 7 years. This visualization shows the proposed route for the rover. It will explore the aptly named clay-bearing unit before marching onwards and up Mount Sharp into the sulfate-bearing unit. The rover may eventually reach Gediz Vallis Channel, which has an uncanny resemblance to an ancient river. Curiosity looks toward the clay-bearing unit and sees waves in the foreground. Toward the left of the image is a portion of Vera Rubin Ridge. Scientists are trying to figure out why that ridge has resisted erosion, and yet the clay-bearing unit is much softer. The clay-bearing unit is an eroded valley between Vera Rubin Ridge and higher regions of Mount Sharp. The best explanation for why this valley has been eroded is some form of massive environmental change in the ancient past. As clay-bearing unit doesn't exactly roll off the tongue, the team at NASA renames the area Glen Torridon, after a narrow valley of the River Torridon in Scotland. Just as the rover is making good progress, it experiences a hard reset and automatically enters safe mode. The team at NASA has since isolated the memory problems on the B-side computer and so switched the rover over to that side once again. Curiosity steadily gets back to business by first observing a Martian eclipse. This is the moon Deimos, the smaller of the two Martian moons, passing in front of the sun. On Sol 2356, the rover comes across an incredible patch of pebbles in Glen Torridon. These rocks look like they've possibly been rounded by water over a long period of time. Curiosity looks to the sky once again and is lucky enough to see the other Martian moon, Phobos, passing in front of the sun. This series of images shows that Phobos is the larger of the two moons, at about 8 miles or 11 kilometers in diameter. The eclipse lasts about 35 seconds in real time. On Sol 2372, Curiosity gets its first taste of the clay-bearing unit at a site named Aberlady. The drilling is a total success. When looking at the before and after images, we can see that the drilled rock and terrain surrounding it appear to have moved when the drill was retracted. The rover looks up and sees Martian clouds. These are likely water ice clouds about 19 miles or 31 kilometers above the surface. These clouds are so high that they are still illuminated by the sun, even when it's night at Mars' surface. Scientists can watch when light leaves the clouds and use this information to infer their altitude. The rover takes another drill sample nearby, and you guessed it, takes a selfie in celebration of a successful drilling. On Sol 2407, a wheel check is initiated. Nothing surprising is found. The team's damage mitigation efforts, driving over softer terrain, seem to be working well. There is also a plan B, in case the damaged wheels get in the way of the mission. The team would order the rover to scrape a wheel against a sharp rock, hacking off any bits that may damage some of the rover's more sensitive components. Curiosity views more clouds before setting off on a drive. The rover looks back at its tracks from its new location, known as Teal Ridge. By driving up the side of this ridge, the rover has access to an exposed unit of rocks. The rover takes a closer look at a site named Strafton. This boulder-sized rock has some interesting layering. An even closer look using the camera on the rover's arm shows the rock was created by the hardening of sediments deposited from both water and wind action. Curiosity takes a huge risk and climbs a very steep hill to get on top of a ridge, loses its balance, and takes a 1.8 billion pixel image. After taking 2 drill samples at a site known as Glen Etive, Curiosity takes a selfie. These annotations show the crater rim in the distance, as well as Vera Rubin Ridge. Curiosity has made a lot of progress through Glen Torridon, formerly known as the clay-bearing unit. While the team at NASA celebrates Thanksgiving, they order the rover to complete its biggest panorama yet. This image contains nearly 1.8 billion pixels and is the most detailed image ever taken on another planet. The view looks over the whole Glen Torridon area, with Vera Rubin Ridge in the distance. We can see the rover's tracks through the clay-rich unit. As we zoom in on the formidable Mount Sharp, we can see a ridge. This is part of what's known as the Green Hue Pediment, and Curiosity will eventually have to climb up it in order to access higher layers on the mountainside. Curiosity makes good progress towards the Green Hue Pediment and currently sits on a small hill known as Western Butte. The plan for now is to simply drive up to the green hue pediment to get a better look at the rocks there. This visualization shows the proposed route. The rover is currently on its way to touch the green hue pediment before it will track back around into the clay-bearing unit once again, and then head to a more accessible route onto the green hue pediment. The rover edges closer to the green hue pediment. Geologists desperately want to gather data from the top of the structure, and so talks begin among engineers about a possible climb for Curiosity. Then, on Sol 2649, Curiosity wakes up with a bad attitude, quite literally. The rover is feeling dizzy and stops all operations. Just like us humans, Curiosity needs to have an awareness of itself relative to its environment. This data is normally stored in its memory and tracks things like the angle of the slope it sits on, how close its arm is to the ground, and if there are any big rocks nearby that could pose a hazard. The rover evaluates this data before engaging any motors to make sure that any movements can be performed safely. When the answer is no, the rover freezes in place and waits for the ground team to guide it on the next route. The team at NASA discovers a problem with Curiosity's attitude. The aerospace definition of attitude is how an object is placed in a 3D space. Basically, it's 3D orientation. So we can confidently say that Curiosity currently has a bad attitude. After the ground team informs Curiosity of its proper attitude, the journey continues. This map shows Curiosity's current location on Sol 2654. The rover is now very close to the overbearing green hue pediment. To access data from the top of green hue, the rover will have to start climbing. Although this takes the rover on a little detour from its proposed route, the engineers agree that it's possible and worth the risk. Before making the climb, Curiosity uses its dust removal tool on a nearby rock. Multiple exposed mineral veins are present in the image. The team decides this area would make a good drill sample, so Curiosity drills another hole, this time on a rock feature called Hutton. The drilling goes ahead perfectly without any issues and produces gray amorphous tailings, enough for the sample inlet. If you've noticed, each time the rover drills, the colors of the tailings are different from the reddish surface. This is the first hole the rover drilled on Mars. Evidently, the tailings in this hole are reddish in color, similar to the interior of this drill hole at the Aberlady site in the clay-bearing unit. But here at Hutton, it's more grayish. Can you guess why? It's because oxygen reacted with iron in various parts of the rock differently. The tailings on the left are red because oxygen had the opportunity to react not only with the external rock surface, but also the interior. However, the image on the right tells a different story. The oxidation could not penetrate deeper into the rock in this case. This is particularly interesting for scientists because this kind of sedimentary rocks can house the traces of organic life in the past. Rocks preserve traces of ancient life better when they are not oxidized, because oxygen can break down the organic materials before they fossilize. Although the rover's drilling went well, it was far from elegant. The surface Curiosity sits on is so brittle that the rover's wheels crack the sedimentary rocks, turning them into detritus and powder. As it looks for a way up the green hue pediment, the rover catches an incredible close-up view of the ridge from below. These stratified layers are called nodules. These rocks are completely different from those of the clay-bearing unit, but somewhat similar to those we saw at Vera Rubin Ridge. Another Sol on Mars, and another chance for Curiosity to take a selfie after its successful drill campaign at Hutton. From the data that Curiosity has collected so far, scientists are now convinced that Gale Crater was an oasis of water in the ancient past. Water ran through the Geddes Vallis Channel and spilled out into the clay-bearing unit. The green hue pediment resisted erosion and essentially became one big shoreline. On Sol 2693, Curiosity begins the climb up the green hue pediment. These raw images show the angle of the rover as it climbs. The incline is more than 30 degrees. It's considered a very risky move, but engineers are comforted by the fact that it's not the steepest climb a rover has performed on Mars. The Opportunity rover previously managed an even steeper climb, yet only by fractions of a degree. The rover quickly takes a drill sample from the top and looks toward Mount Sharp. There is no viable route from here, so the rover must descend the hill and get back on the official path. As the rover turns around to descend, it captures an incredible view from the top of the Greenview pediment. In the distance, we can see the crater floor where Curiosity began this formidable journey. The rover is really making strides now. Curiosity continues to climb Mount Sharp, captures stunning images, takes more selfies, and makes good progress toward an ancient river channel. Curiosity is currently watching a dust devil from its position at a site known as Mary Anning. The dust devil is estimated to be about 16 feet or 5 meters wide, and at least 164 feet or 50 meters tall. The frames in this sequence were captured over 4 minutes and 15 seconds. The team decides it's a good place to take some drill samples and orders the rover to go ahead. Curiosity drills 3 holes. This time-lapse shows one of the drill attempts. In reality, it took the rover over 20 minutes to complete, using the feed-extended drilling method, which still seems to be working well. Engineers responsible for the drilling can instantly tell that the rock is very soft, based on the data from Curiosity's pressure sensors. It was so soft, in fact, that no percussion was required, only rotation from the drill. Curiosity celebrates in the usual way by taking a selfie. The rover will now spend a few sols putting together one of its most beautiful panoramas yet. In this image, some NASA scientists have described what they are seeing as a series of benches descending toward the crater floor in the distance. It's certainly a great view from here. The crater rim can be seen in the background. Curiosity turns around to continue the climb up Mount Sharp and comes across some interesting terrain. The closest outcrop is named Mont Mercure. Mount Sharp looms behind the other outcrops. While looking up, the rover captures a special type of cloud. These iridescent or mother-of-pearl clouds are sometimes spotted here on Earth at high latitudes, but are very rare. They radiate different colors and occur when clouds are very high in the atmosphere. This type of cloud might actually be more common on Mars due to the thin atmosphere. The rover approaches Mont Mercure and takes 2 mosaics from slightly different positions. When put together, these images create a 3D effect. The rover team spots some clouds behind Mont Mercure. They order Curiosity to take a few more images, which are then combined into a video sequence. Each frame of the sequence is made from 6 individual images. The rover takes a selfie near Mont Mercure after a successful drill campaign at a site named Nontron. It's named after a village in France because the area on Mars contains nontronite, a rare type of clay. The mineral was named after the area that it was first found, the French village Nontron. Curiosity spends a little more time observing clouds before setting off on a big drive. The team orders the rover to look toward a mountain in the distance, and they give it the name Rafael Navarro Mountain, after the astrobiologist Rafael Navarro Gonzalez, who worked on the mission until he passed away on January 6, 2021. This image shows the proposed route. Curiosity will pass alongside Rafael Navarro Mountain and then climb up onto the Greenview pediment once again, before proceeding to the exciting Geddes Vallis Channel. Before doing that, Curiosity cannot resist climbing up on top of Mont Mercure and taking a panorama. The other side of Mont Mercure is relatively flat, so it was an easy drive for the rover. Still, the team at NASA won't allow the rover to get too close to the edge. After a long drive, Rafael Navarro Mountain comes into range. The rover will pass alongside this to access higher layers on Mount Sharp. Curiosity finds what looks like a Martian flower, finally reaches the start of the ancient river channel, and finds flaky rocks that look almost identical to rocks from streams or rivers here on Earth. After a short solar conjunction, the rover is back online and looking at some strange nodules on the ground. They are seen in abundance in this area, and the team orders Curiosity to crush some using its wheels. The crushing doesn't go entirely as planned, but reveals a shiny substance within the rock. The rocks seem to be getting harder than those seen in the clay-bearing unit. The rover is making good progress and coming up to a small passageway between the green hue pediment and another big outcrop. This is given the name Maria Gordon Notch. Curiosity took this image on Sol 3299, and it's been described as a picture postcard from Mars. It shows the path back down Mount Sharp, and Rafael Navarro Mountain can be seen on the right. Curiosity takes a selfie on the way to Maria Gordon Notch. The rover will now pass through. On the way through, the rover takes this incredible mosaic. This could be the best image ever taken on Mars. The overhanging ledge, the abundance of mineral veins, and some strange features all make this outcrop very interesting. Just look at this huge vein. It's resisted erosion while the surrounding rock has been slowly consumed by many years of water or wind action. At the top of the outcrop, there are some strange-looking nodules. Why is it that these nodules only appear on top of the structure? Could it be possible that the area was once a flowing river and those nodules couldn't form under the intense water pressure? Curiosity would love to stay here a little while longer, but it has a mountain to climb. On Sol 3325, more clouds are observed in the Martian sky. You can see their shadows rolling across the landscape. This series of images shows the view directly above the rover. On Sol 3396, Curiosity finds what some people are describing as a Martian flower. This strange object is smaller than a coin and is covered by a thick layer of Martian dust. At first glance, it looks like a plant. However, NASA believes this to simply be a cluster of mineral veins left over after the host rock completely eroded. We don't often see formations like this on Earth due to the higher gravity and denser atmosphere. On Sol 3415, Curiosity decides to once again climb up on top of the green hue pediment. The rover takes this mosaic at the top, but there's a problem. The top of green hue is littered with what scientists are calling gatorback rocks, which could damage Curiosity's wheels. The rover will have to get back down and find another way into the river channel. This view of green hue shows a sloping landscape in comparison to the level layers of the outcrops in the distance. Could green hue have been an ancient slope into water? The rover takes a closer look at these sharp rocks before descending once again. This is the second time the rover has climbed and then had to descend from the green hue pediment. On Sol 3492, the rover comes across some flaky rocks that look almost identical to some rocks back here on Earth created by streams and rivers. On its 10th birthday, the rover sits here at the start of the Geddes Vallis Channel. Its journey has been incredible. Curiosity has driven 17 miles or 28 kilometers. Curiosity has acquired almost 500,000 images, transmitted 31 terabytes of data, climbed more than 2,000 feet or 612 meters, and its findings have given way to 883 academic papers. The rover has proved beyond all reasonable doubt that water was once prevalent on Mars, and not just acidic water, but fresh water suitable for the creation of life as we know it. Curiosity has well outlasted its primary mission and will continue to roam the Martian surface for many years to come, until the failing of its final instrument. A newer generation of rover is already on the Martian surface, called Perseverance, doing everything that Curiosity could and more. The inclusion of a microphone for capturing Martian sounds, a helicopter to scout ahead, and higher quality cameras all make Perseverance the superior mission. But does it have the curiosity to continue? Click here to see our series on the Perseverance rover, to see if it will in fact outlast Curiosity. Thanks for watching Elder Fox. Please share this series with anyone who doubts that Mars once had liquid water.
On June 10, 2003, a rocket took off from Cape Canaveral, Florida. Its lone passenger, an explorer on a one-way trip to Mars. His partner, an identical twin, followed soon. They were born in California, endowed by a loving family with all the intelligence and skill humanly possible. But the explorers themselves are not humans. They're robots, designed to go places and do things that humans cannot do. To their creators, they're much more than machines.
First time I stood there and watched it dry, it brought tears to my eyes. I tried to understand what Space Explorer did, but that one I just couldn't take it. There was just too much to see. It was just, it's a phenomenal.
For centuries, Mars was an home of war and disaster. Today, it's a destination, but still dangerous.
We've lost about 50% of the missions that we've flown to the planet. It's a tough place to operate.
But the attraction is irresistible.
What's the single most important question of the day in life in space science? Are we alone when we go to Mars? Here's most likely place that life might have arisen elsewhere in the solar system. What we really do is we're asking questions about who we are and where we come from. Maybe life evolved first on Mars and was knocked off the surface and carried to the Earth. Maybe we're all Martians.
If so, the proof is out there. But first, our explorers must survive the most dangerous part of the journey. Landing on Mars. Tonight, Nova presents an exclusive behind-the-scenes chronicle of this great adventure. Mars, dead or alive, right now on Nova. It's the summer of 2002, and the Steve Squires is on the road. He's a professor of astronomy from Cornell University in Italy. In the past few years, he's logged almost 1 million miles, commuting to NASA's Jet Propulsion Lab, JPL, in Pasadena, California. This is where NASA builds spacecraft to explore the solar system. At the moment, they're building 2 of the most sophisticated ever attempted. Twin Rovers designed to unravel the secrets of Mars. These rovers are the ultimate custom machines. No stock parts, nothing off the shelf.
This is a general manager. We're not building pickup trucks. These stuff that you see here has never been done before.
A year before launch, the rovers and science instruments are bits and pieces of hardware scattered through a dozen different buildings. Steve Squires is the lead scientist and the driving force behind the mission. But the engineers will make it happen. More than 600 people at JPL are dedicated to M1, Mars Exploration Rovers. It's a demanding job with an unusual payoff.
I think it's easy to forget about the big picture when you start getting a little tired and burned out. Then you start thinking, why am I complaining? I'm going to work to drive a vehicle on another planet.
And not just any planet. Mars has tempered us for centuries, with a confounding mix of the familiar and the bizarre. Canyons miles deep and thousands of miles long. A volcano the size of Arizona, and 3 times the height of Mount Everest. What water there is on the surface is frozen at the poles. There's evidence of more ice underground, but so far, not a drop of liquid anywhere. It's a frigid, almost airless desert of dust, wind, and radiation. Even for a robot, it's a hostile environment. But these rovers will be prepared for the worst.
There would be a place where there's dust to get into the joints and the temperature goes to 100 degrees centigrade between nighttime and daytime. But this was the world that they were designed for. And so I think they're going to do it.
The lure of Mars is the possibility that it wasn't always such a harsh and barren place. From orbit, we see ancient signs of water flowing across the surface, which could mean that Mars was once warm enough to be wet, and perhaps a habitat for life.
Just because there was liquid water there doesn't mean that there was life. We cannot imagine life without liquid water. So it's a necessary condition. I will go to 2 places on Mars where we got good evidence the water was there. Answer the question, was this an environment that would have been suitable for life?
The rovers will be field geologists reading the story of early Mars recorded in the rocks and minerals. Scientists on Earth will send instructions. At the speed of light, it will take 10 minutes or more for radio signals to reach Mars. So the rovers will have to be smart enough to make many of their own decisions, like how to navigate around hazards. They'll have high-resolution stereo vision to survey the landscape, plus an infrared camera called Mini-TESS to locate minerals that formed in contact with water. More science instruments are on the robotic arm. Prying off the weathered surface of a rock. 2 spectrometers to sniff out what it's made of. And a microscope to examine its interior. It would be hard enough to make all this work on Earth. But to make it work on Mars will be extraordinarily difficult. And the engineers have just 12 months left to pull it off. Today, the instrument called TESS is scheduled for a test. Because it can detect movements that formed in contact with water, it may be the single most important instrument on the mission. They have to prove that this delicate piece of hardware is tough enough to survive the shocks and bumps it will experience on the way to Mars. It will be bolted to a slab of aluminum, which will then be struck by a gas-driven hammer, giving the instrument a severe jolt. Steve wants to make sure the engineers don't overdo it and break the instrument.
NASA ultimately holds me responsible for delivery of the scientific instruments. I'm not an engineer, but I take my responsibilities very, very seriously. We break some hardware. That's going to be my neck on the line, with a whole bunch of others. Break this today, $5 million. Let's make sure everybody's
Steve is worried because the point of this test is to prove that the instrument is tougher than it needs to be, what engineers call margin. But such tests are not usually done on the actual hardware going to Mars.
Which engineering, which is another copy of the flight instrument, identically designed but not one that's for Mars. Put it on the table, shock in. If it survives, the sign's okay, we don't have to do it for flight units.
But at $5 million apiece, they could only afford to build two, one for each rover. A mistake here could cripple all of them and not leave enough time to recover.
That's what I'm trying to get at. Is there something we could break inside the system today? It's going to cost $6 million. Look, it is.
The engineer who knows the instrument best is Steve Silverman from Redfield. Squires wants to know if it can survive this severe jolt, or if they should insist on a less dangerous test.
Do the test. I don't know if the nemesis is should be able to survive it. Now, will we? I can't answer that. I'm not asking for a prediction. Okay, I'm asking for, it's a binary thing. Either we do the test or we don't. What's your recommendation? Strap it to the table and shoot it off and walk out of here with our instrument. We can cause all sorts of hell for a lot of people today, and we can't bring this whole project down. There's a natural, built-in, creative tension between the science and the engineering, and ultimately, even though it gets people kind of riled up sometimes, it works for the benefit of the system. Okay, so your recommendation is
Project is going to require a qualification test. We should do it. Break it.
We're going to break it. We ought to break it as soon as possible. All right.
Finally, the moment of truth. No one will breathe easy until the results are in. Steve has to move on to other business, leaving the post-mortem for the engineers.
Hey Steve, I'll give you the good news. We turned on mini test 1. It's working great. It survived the shock test. I'm pretty happy. So I'd like to hear it. Have a good flight and see you next time.
He needs all the good news he can get. The clock is ticking, and Mars waits for no one. Every 26 months, the orbits of Earth and Mars bring two planets to a brief, relatively close encounter, about 35 million miles apart. This is when missions must be launched, and the next opportunity is rapidly approaching. If they miss it, they may not get another chance, since it will cost millions to put everything on hold for 2 more years. And that's not all there is to worry about. Everyone remembers what happened the last time NASA tried to go to Mars. In 1999, a mix mix-up between English and metric units resulted in the loss of an orbiter. Just a few months later, a software problem caused the lander to crash. Mars is a graveyard for half the spacecraft ever sent there. But this time, they have to succeed.
I think the credibility of the Jet Propulsion Laboratory is at stake. I think that the credibility of NASA's Mars program is at stake. A lot of science is at stake. It's 10 or 15 years of my career is at stake. It's one of the really personal things. There's an enormous amount at stake here, and everybody realizes it.
10 months before launch, the engineers are feeling the pressure. They've been working around the clock to complete an engineering of the rover. It has no instruments or solar panels yet, but otherwise it's identical to the ones that will go to Mars.
There are several thousand unique pieces of hardware, each one precisely placed, but never perfectly placed. It's really freaking hard.
Today is the first in a long series of tests to find out if the rover can perform its most basic functions.
That very first test, when you first see it happen, the technical part of your brain says, this has to work. That emotional part of your brain is saying, yeah, but you forget it. You're not as smart as you think you are. And let's just say we never get past that fear until we're successful.
Wheels turn for the first time. And suddenly, Mars is much closer.
We just saw a Mir rover boom. It just came to life for the first time today in front of us. I mean, we're still under pressure, but we're doing it. We're actually doing it. We're building stuff, we're driving stuff, we're taking pictures with the cameras, we're moving the arm and it's working. The morale right now is the highest I've seen since the start of the project.
But the rover will have to get a lot more sophisticated if it's going to survive on Mars. And the biggest challenge will be the last 6 minutes of the journey.
During and pre-descent landing, the rover is on its own. There's no back and forth between the vehicle and Earth. We've taught it what to do, and it does it, or it doesn't.
Atmospheric friction will slow the spacecraft from about 12,000 to 900 miles per hour. Then a parachute takes over. The heat shield falls away, and the lander descends on a long bridle. Now the rover inside keeps track of the altitude with radar. At 900 feet, a cocoon of airbags inflates around the lander. Just seconds before impact, reverse rockets fire to soften the blow.
They bounce, bounce, they bounce, they bounce, they bounce, they roll, they bounce, they roll, they bounce, they roll. And that can go on for quite a while. I mean, we can roll and bounce like a kilometer.
The landing sites have been chosen as safe.
But I can't tell you that somewhere in the middle of that there isn't a 5-meter tall, pointy, sharp rock. That if you just happen to have a bad day and you land on top of your airbags, and that's it. There is an element of luck.
Still without help from Earth, the rover has to unfold itself and call home to say, I've arrived.
Every one of those events is triggered by the computer. There are electrical signals, there are things that have to fire, and there's stuff that needs to work. Any one of those events fails, for whatever reason, we're done. So there's a lot of things that go wrong. And one day we hope it all works.
Of all the things that could go wrong, the airbag seem the least likely to cause trouble. It's a relatively simple idea. Inflate a cushion around the lander and let it bounce. To test the bag's pressure, they have to duplicate the atmospheric pressure on Mars, which is less than 1% of the atmosphere on Earth. For the first test, they go to the world's largest vacuum chamber at a NASA facility in Ohio. The chamber is pumped down to a near vacuum. They'll inflate the bag and drop it on a platform studded with sharp rocks to simulate landing.
We went out to do these great and glorious tests and showed everybody that, hey, things are going to work. Don't worry about this, guys.
So we're all sitting in a control room. We've got half a dozen video cameras looking at all sorts of different angles. And everyone's sitting around saying, and drop. The airbag comes down, hits the ramp, and as it's bouncing off the ramp, you see this huge gaping hole in one of the airbags. What's happened here? This is unexpected.
It was a frightening moment. We all believed that we could make it happen, but all of a sudden, we didn't know how it was going to happen. And we really had to rethink everything.
They were caught by surprise because they'd done all this before. Highly successful mission from 1997 called Pathfinder. Its purpose was to demonstrate what was then a radical new concept. A controlled crash landing with an airbag, and a fold-up lander inside carrying a small rover. Pathfinder didn't produce a lot of science, but it did prove that the landing system and rover worked on Mars. It worked so well, NASA decided to use the same technology for MER.
Go with what you know. We had a success. Take the drawings off the rack for Pathfinder, build a new site. Except Pathfinder got dinged for not having enough science return. So we're going to up the science return by stuffing a big rover inside of this thing.
MER is the Pathfinder rover on steroids. It has bigger wheels and suspension to handle rougher terrain. It carries all the cameras, radars, antennas, and the computer that runs everything, which on Pathfinder were all part of the lander. Plus the payload of science instruments and the robotic arm, all of which require more power, meaning bigger solar arrays, more electronics, and a heater to keep things warm at night. It's the ultimate off-road, off-Earth mobile science laboratory. And yet, because of space limitations on the launch rocket, this pumped-up rover is fitting on the same size package that carried Pathfinder to Mars. And that's a problem. The solution is a complex fold-up rover that will have to unfold itself after a long, cold, rough trip to Mars. And the whole thing weighs 50% more than Pathfinder, which is an even bigger problem. With the airbags struggling to handle the extra weight, it's even more important now to get the best possible performance from the parachute to control the velocity when the lander hits the ground. The first parachute strength tests will tell them where they stand. The chute will be deployed from this giant dart as it's dropped from the...
We go to these first tests. Beautiful day. We're very confident.
On Mars, the parachute will open at more than 900 miles per hour. But in the denser atmosphere of Earth, the same stress on the chute will be achieved at a much slower speed.
We have this massive structural failure. parachute rips apart. And we're all kind of stunned. First the airbags, then the parachute, and it sets in on us that we're going to have to magically find time in our schedule for a redesign cycle and prove that we have the entry-descent landing system that will take us to Mars.
All of a sudden, your whole world becomes that tear, that rock. Why did that happen? How do we fix that? What are we going to do? The whole mission is right on fixing those kind of problems. It's a terrifying moment, but at the same time,
There are moments where there's an at-all-cost component to the effort. And it can get you down. You find yourself eating a lot, drinking too much. And it's really important practice to keep on top of this stress. I'm exercising more than I've exercised in my entire life. I'm working out once a day at least, because if I don't, I go crazy.
Landing on Mars has never been easy.
The Russians tried 7 times to land on Mars before we ever did. One spacecraft lasted for a few seconds. All the rest were failures. If it were easy to land on Mars, people would be doing it all the time.
Before Pathfinder, the only successful attempts were the Viking landers in the 1970s. It was NASA's golden age, with powered landers, 10 years of development, and 4 times the $800 million budget of any other.
There was $900 million in 1973 dollars, which is $3.5 billion today.
The Viking orbiters produced tens of thousands of pictures, a complete photographic map of the planet. But a primary mission was to look for signs of life on the surface, and that search was empty. What Viking did find is a distinctly unfamiliar environment for life. 150 below zero at night, very thin atmosphere. No protection from solar radiation. No organic chemicals in the soil. No liquid water. The verdict at the time was that Mars is dead.
The search for life dominated all of the public and governmental interest. And life was not found by Vikings. Then it was a disappointment. And we had no Mars missions for 20 years as a consequence.
This time, the strategy will be different. The dried-up river channel seen from Earth suggests that Mars was not always as barren as it now appears. Scientists can imagine an early Mars where liquid water flowed across the surface, forming lakes and even oceans. On Earth, wherever there's liquid water, there's life. Even in the most hostile environments like hot springs, beneath Arctic ice, and deep underground. In the search for life on Mars, NASA's current strategy is to follow the water.
If we can find the places on Mars where water pooled, then that's where you want to go. That's where you want to look for life. So water is, if you will, the scent of the life you're looking for.
There are many places on Mars that may once have been wet, but only a handful where the rovers can actually go. They're solar powered, so they need to be near the equator where the sun is almost directly overhead. And within this narrow band, they can land only at the lowest elevations, where the parachutes will have enough time in the thin atmosphere to slow the landers before they hit the ground. That eliminates 95% of the planet. Much of what's left is too dangerous for landing or for operating rovers. After 2 investigation down to a small handful of possible landing sites.
We're a week behind in some unsafe sites, so
This is where it gets difficult.
Believe me, these sites are not all created equal from a science perspective. Some are very exciting, some much less so. And they're going to be chosen largely on the basis of their safety.
Scientifically, this thing has nothing going for it, so...
You all understand the threat I'm trying to protect us against, right? Which is that we have... There's this natural tension between the scientists and the engineers, because the engineers are the ones who have to tell the scientists the possibility of failure if we do what you want is too high.
One site they can all agree on is called Meridiani Planum. It looks relatively safe, and orbiters have detected a large deposit of the iron mineral gray hematite, which on Earth usually forms in the presence of water. But the scientists want very badly to try something more adventurous for the other rover.
There's a place called Gusev Crater, big impact crater, maybe 100 miles or something across, and it's got this huge dried up river valley flowing into it. It's hard to believe that this thing didn't have a great big lake in it at some point in Martian history. Sediments are going to be deposited in that lake. You should have a good sedimentary record of liquid water and whatever was going on there. So Gusev Crater is a fabulous place to go.
But Gusev may have strong winds, and that presents a serious hazard for landing. Just before impact, reverse rockets will fire for a few seconds to reduce velocity to something the airbags can handle. But if the wind is blowing the lander along horizontally relative to the ground, or causing it to swing when the rockets fire, the lander could hit the ground with too much horizontal velocity and potentially disastrous results. The engineers have added another rocket system to counteract some of that sideways velocity. But it may not be enough to handle a worst-case scenario at Gusev Crater.
The engineers know that the science team wants this site, and we want to go where they want to go. But we will not go where it's too dangerous to go.
The final decision will be made at NASA headquarters. But for Gusev to be an option, the engineers will have to get maximum performance from the problematic airbags and parachutes.
We're working nights and weekends to try and get that job done.